Welcome everyone to Magic Models V1.0, and today we're welcomed by Stepan and James, and we're really looking forward to this webinar for a while, seeing the work that these guys are doing and their kind of custom tools and custom workflows, and the Spellshape platform and ComfyUI use. Um, so I'll give a short introduction. Stepan is an award-winning architect, content designer, co-founder, and CTO of Spellshape, partner at SA Lab, tutor at Digital Futures, ECAD, and more. And James is an Irish computational designer and educator at the Institute of Advanced Architecture of Catalonia, or as you all know it as IAC, um, where he teaches in the Masters in Advanced Computation for Design, for Architecture and Design, MACAD. He has also taught at EX Global Summer School, Digital Futures, and University of Calgary, University of North Texas, University College Dublin, and Oxford Brookes University. His background includes operating a CNC workshop, running a successful Kickstarter campaign, and gaining experience at KPF, JDS, and OMA. His research embraces a broad generalist interest in computation's role within design. He is also currently pursuing a master's in computer science at Georgia Tech, building on earlier degrees from EIC and University College Dublin. So welcome, guys, and I just want to remind you, Stepan and James, uh, if you switch your chat to everyone, if you haven't already, this way, just to make sure that if you want to send them stuff, that it's not just sending between us. I always forget that myself personally. And then everyone else in the chat also, you'll want to switch your chat to everyone if you want to be part of the larger chat discussion. This webinar is recorded, and so if you feel like you can't keep up, or if it's too much, or if you're having trouble installing something, feel free to just kick back and watch, and you can always go back to the recording later. Once Zoom finishes processing the recording, we will email a link for the recording for the people that are signed up for this. Will get access by tomorrow, the latest, and then within a few weeks it will go on YouTube. Um, and yeah, that's about it from my end. If you guys want to jump into it.
Yep. Thanks for the introduction. Uh, I see people already have this Notion link we wanted to share. It has complete access to all the information we'll be sharing during the webinar. Uh, Thank you, James, for doing this. Super helpful. Um, so I think I'm the first one to begin. A bit nervous and excited at the same time. So let me start sharing my screen. Hopefully you can see it now.
Yep, we see it all good.
Okay, so this Notion page, just a brief summary, what we're going to talk about here, who we are, just in case you want to get in touch, some links for LinkedIn and Instagram. For Spellshape, you don't need to install anything. Just follow this link that is here in this Notion page. This is a demo link because the Spellshape the project is a work in progress, not finished, nothing fancy there yet, but we are going to it. Once it all working as supposed to be, it will be live on this official website, spellshape.com. But for now, it's going to be this demo link. Regarding the ComfyUI workflows, if you want to start installing it right now, you can follow the instructions here. Otherwise, if you have this already, it's great.
Um,
Because
I'm going to go
we
through it later just to add. It's a lot to download. Um, if you're on a slower internet connection, it might be worth downloading the models in particular, which would be the largest files. which will be in the ComfyUI folder. And there's a link just to the model, specifically the Flux 2 model.
Yep.
But no
Okay.
need to download Flux 1 and SDXL. It's just optional. I put the links in there. But Flux 2 is a relatively small model and very fast and good for the workshop. So,
All right. Now let's start with some slides. Okay, so let me briefly tell you about who I am and how I ended up working on Spellshape at the project. I'm an architect and computational designer, doing computational design, I guess, for 15 years now. And at some point, I started building my own tools, going from online code editors to AI sandbox tools with chat-like interfaces. And at some point, experimenting with 3D generation, I thought that we could try a different approach compared to what was popular at the moment and still popular with diffusion models. And the idea was to use large language models to generate 3D. And that's how I started working on Spellshape. Spellshape is now developed by 2 people. I'm the technical guy here, and I work together with my colleague Alina. She's basically running everything else apart from technology here, like design, network, and all other topics that are not covered in technology. But since I'm the technical here, I will mostly speak today about technologies behind the platform, the issues, and I would say please don't be very excited about how it all works, because I think 90% of the time it won't work the way you expect it to work, and there are reasons for this. And I will go through them, and we will try together to make something and to model something. Yeah, let's dive deeper into the topic. Okay, Notion is covered. Okay, one quote I found on LinkedIn that I liked a lot, but I don't remember who posted it and where I got it. So it's just let it be an anonymous quote. AI is exceptional at building, but it's terrible at knowing what to build. I really think that AI is great when you tell it what to do, but it's up to you to decide what exactly you want AI to do. In other words, you cannot leave reasoning process completely to AI. You have to reason yourself and then go with exact tasks. That's how it's gonna work. And we have a kind of, it was James' idea. By the way, his presentation is pixel perfect. I so loved his presentation, the colors, and how everything is assembled. So mine is a bit less, I don't know, graphic polished, but still I have some thoughts I wanted to share with you. And he'll be talking a lot about collage as a technique and how you can use it with AI. And at some point, I thought that probably collage is kind of a topic that goes through this whole webinar, despite that the webinar is on 3D generation. We still cover a lot with large language models, which can be treated as one-dimensional generation because they think in tokens and it's kind of a line of tokens that gets predicted. But at the same time, they have a lot of parameters inside them, thousands of them, that help them predict those tokens. So it's not clear the dimension here. James will cover 2D collage techniques when you work with images, and of course 3D collage techniques. And I've been thinking about this topic for a few days now, and probably everything we see around us is a collage of something, a collage of sounds, a collage of images, and the world we live in is a collage of different things happening with us, different life circumstances, and it's really a deep philosophical topic here. When we think about 3D generation with generative AI, it's probably the hardest problem that is still unsolved. If we talk about text generation, we have a full internet of different texts available to train models. When we talk about image generation, we have full internet available of various images that you can use to train models. When you talk about 3D, first of all, there are not so many resources available where you can get those 3D models. Second thing here is that 3D is a completely different process compared to text generation and image generation. When you generate text, it's fine if some words do not match. For example, if we take early stage models, but then you increase the data set and you get a better model and a better prediction. Same thing with images. When you try to generate an image of a chair, it doesn't matter that some pixels are not perfect, that the leg of a chair, for example, is shifted somewhere. You still get the image, you still get the representation of a chair, and you still understand the object depicted there. When you talk about 3D, if the leg is not positioned properly, then the whole model is not appropriate. And there are two ways, I think, to do this 3D generation with AI, especially if you want to edit the mesh later, if you want to own the geometry, if you want to download it and somehow tweak it later. And these methods are large language models and let's call them 3D diffusion models. And we're going to cover two of these directions during the webinar. That's how we got the idea of the webinar, me and James. You can correct me if I'm wrong and I'm forgetting something here. Of course, there are methods like splats, Gaussian splats, nerves, and so on, but they end up in points of clouds and not in the editable geometry that you can download and tweak later on. With large language models, when I first thought about this idea, I thought that having large language models to generate 3D is a great idea. I thought that they are so good at coding that you can ask them to create a program to generate a chair, for example. I'll be talking a lot about chairs today because it seems that it's so ordinary object in our life, but yet it's so different. There are many chairs around us. They are all different modeling techniques, different assembly techniques, different production techniques used. That's why I keep going it as a back to chair as an object, because it's a great example. And I thought that this is going to be cool. And when LLM writes code to generate a chair, that means that it creates a logic, it creates all the variables, it creates all these parametric equations and expressions, and basically it provides you with the logic that generates the chair, not just the final model. And you can add some sliders, and you can tweak your model later. You can adjust the height of legs, for example, the widths, the depths of different objects composed into a chair, and so on. But then, spending 6 months trying to generate a simple chair with large language models, I was almost desperate. And right now, I spent like almost 9 months working on this and trying to use large language models to generate something. And it's so strange. They seem to live in kind of a different world. And when you talk to them on a daily basis, it's so kind of unreal, the 3D world that they have inside. And it's completely normal for them, but it's very, very unusual for us. And the reason here is that, for example, like looking at this image here, a chair here. This chair has 2 legs, and it's completely fine for a large language model to output a chair with 2 legs. And you can say, like, okay, just make me a chair with 4 legs, and then it will fix the code it produced. But then you see on the image 2 legs again. And when you try to check what's going on, it appears that there are legs positioned at the same coordinates. For example, you have 2 legs at the same location. And when LLM is trying to check the code that it wrote, it gets 4 legs. It says, okay, I fixed now. Now it has 4 legs, but you see the image and it has 2 legs. And this is what's happening. And the issue is that large language models do not have spatial reasoning. They do not understand the 3D space. It's okay for them to have columns, for example, horizontal. You ask for a column in your scene, you have the column in your scene. It's just that it's horizontal instead of being vertical. And the reason for this spatial reasoning lack is that the way large language models work, they predict the next talking. They do not go back and forth trying to understand what was emitted before, what they are going to predict next. That's so they think in a kind of a linear way without looking left, right, or backwards. And there are ways to tackle this, but well, most of the time when you ask it to design a chair, you end up with something like this, like pretty strange construction. And the reason is that they are bad at specializing, and there are some workarounds. Okay, so the reason or the workaround number 1 that I found is that you should not ask large language model to predict the exact coordinates, because it's gonna fail for, I don't know, 99% of the time, because predicting coordinates is very hard for them. They don't see the difference between the numbers and how these numbers relate to each other. But they can use tools to generate these numbers, but they cannot. Sometimes these tools are built into the models, the way I understand the architecture behind them. But it's pointless to ask them to do things like that. But LLMs are great at semantics. So instead, what you should do is ask them to use words to express what they want to do. And these words can be variables that could be later used in the code. These words could be some kind of positioning logic. For example, something is on top of each other, or something is to the left of another object in the scene. And that way, the description becomes clear. Large language models are way better at understanding what is the output they're producing. And this seems to be a working solution. So instead of asking it to generate a chair, you ask it to describe a chair. This is the workaround number one, and this is the core idea I'm using in Spellshape. Because if you just ask ChatGPT, for example, to describe you a chair, you will get great detailed list of parts, how they relate to each other, what is the function, what is the structural purpose of each part, and you even get some images and so on. And the next thing to do with this description is to convert it to geometry. This is what we do in Spellshape. And the core idea is that large language models, they do know about any object you ask them. They can describe this object. They can decompose it into separate parts, and they can describe how these parts are related to each other. And then this text description should be converted into exact 3D model. But with chairs, these are all chairs. Armchair, a stool, for example, a dining chair, chairs produced by famous designers. These are all chairs. This is also a chair, and this is a chair, and this is a chair. And it seems like when you want to generate a chair, it's just not that simple. You cannot just ask to generate a chair. What kind of chair? Should it be a stool? Should it be a dining chair? And then these things, for example, well, if we think about how to model this can be decomposed into parts. It's just kind of an assembly of legs, of seat backrest, and so on, with different kind of design, bending, and all that stuff. These things are pure sculptures that remind chairs, for example, and they are generated, and they are using some different kind of logic, not just an assembly, but sometimes assembly with robots, for example, and sometimes just some computational algorithms behind them. So how do you explain to a large language model what kind of an algorithm it should use? Could it generate such an algorithm from scratch if we are talking about large language models generating code, for example? It's an open-ended question. So when you talk about different approaches using large language models to generate 3D, there are basically three of them, I would say. The first one is that you take an existing software like Rhino, Grasshopper, Blender, Fusion, whatever, and you grab a Claude, for example, and use model context protocol to operate this software. Another approach is that you generate code from scratch. You just kind of ask the large language model to write you a software program that would generate a desired output, a tower, a chair, a more complex project, whatever is your intent. And the third approach that you end up with anyways, no matter what you choose, MCP or code generation, is that you end up with some kind of a language that you need to teach large language model in order to better use the tools you wanted to use. If you wanted to use Blender and you work with MCP, then you need some kind of a library that would allow it to understand the Blender API, what kind of commands it have, what kind of logic behind these commands, and maybe some kind of predefined workflows and pipelines. You could also teach the model so that it doesn't work from scratch every time, but it has some kind of a library, a context to operate on. The same thing with coding, I would say that you would still end up with some ready-made functions to generate some primitives, for example, or simple assemblies or something like that, so that the model would use them as ready-made assets to assemble a program to generate something. And the way we do in Spellshape is we created a set of tools from scratch, and every tool is kind of a semantic helper that helps large language model to position some things, like place on top or place behind, or repeat in a grid manner. I'll talk about this later. So when you try to make large language model to use an existing software, we talk about Rhino, it has hundreds of commands. If you talk about Grasshopper, there are multiple nodes. It should understand the logic, how they combine together, what should go where, and this is a rather complex task. So instead, you end up with creating some high-level tools for large language models. And when you try to create some kind of a library like that, what you end up doing is kind of making exoskeleton for large language model to operate in a 3D space. Just let me know how many of you are familiar with this guy. Now you know how old I am. Let me just understand how relevant this image is in here. Yep. Okay. At least somebody knows where this is. So yeah, this is a character from Ninja Turtle stories, and his name is Crank. It's basically a brain living. Okay, a brain living inside a robot body. So if this seems not so relevant to you, imagine something more modern, like Tony Stark. And this guy, he's an Iron Man. So this is a human with a robotic kind of outfit. I don't know. That's what you have to do for large language models to operate in 3D. Anyways, no matter what are you building, a model context protocol tool or some kind of other approach. So this is the scheme basically. LLM, some library, and then something executing these commands. With Spellshape, we are going a bit different way. A bit more detailed, I would say. So instead of asking large language model to generate geometry directly or output some code, we ask it to design a modeling brief. So basically come up with a process necessary to design this 3D object. And this part is completely generative. The second thing that happens is a procedural. A compiler grabs this description produced by large language models and converts it into actual code. In our case, it's JavaScript that runs in the browser using 3JS library. That's how you get the 3D model that you can then export and use in whatever software you want it to use. So, and this basically gets us to a point where you have to understand what is your final goal. For example, if you want a thing that generates a tower, it can be just a procedural tower generator. Just ask large language model to design your procedural tower generator from scratch with all your requirements, with all the design that you want to incorporate into this tower generator. You can use various approaches. Here you can use like simulations like wave function collapse, for example, to design some neighborhoods out of this tower, or you can use just, I don't know, simple repetitive logic with some rotation to design a single tower skyscraper with, I don't know, some complex skin, but you end up doing something that is completely procedural, and most of the time this is something that is specifically designed for one topic. For example, this can be a tower generator, or maybe a kitchen generator, house generator, something like that. When we do it the way we do, we get some kind of emergent behavior. So when I use Midjourney, for example, or any image generation model, what happens is every time you use the same prompt every time, but every time you get a slightly different image. You do not get one and the same image every time. And in our case, it was not working like a week ago, but during the last week, I finally think we came up with some solution here that is a bit emergent. So with the same prompt, we get a slightly different model every time. So if we ask for a chair, it can be a bit different, sometimes with different details, for example. The more complex the prompt, the more difference you will see. And we have completely manual tools to model something in 3D, like Blender or Grasshopper, and we have completely AI-driven tools like those 3D generation models. Spellshape is somewhere in between, because the way we do it, we kind of generate not the mesh, we generate the logic that creates the mesh, and we give you this logic, and you can tweak this logic later. And I spend a lot of time thinking about the framework for a large language model to reason about the 3D space. I'm not sure this is the correct path or the perfect path, but this is something that, at least I think, somewhat lets large language model to think about various scenes, various objects, and various amount of objects in the scene. So the way we do it in Spellshape is each scene is decomposed into different objects, an array of objects. And these objects are somewhat related to each other. So there is a main object in the scene, and other objects are located somehow on top of it, for example, below it, to the right, to the left, in a radial repetition around it, in some kind of scattered in a space, something like that. Every object then is decomposed into groups that also have some relation to each other. So chair is split into legs, seat, and backrest, for example, or back seat. And of course, legs go below the seat, and the back seat is on top of the seat, but also on the edge of the seat. Then we can also have some subgroups. So each leg can be composed of a series of objects, not just a box, but maybe a few circles or a few spheres, or anything else. And then the wrap part, the smallest item in your 3D model. And these parts are composed of and created with the thing we called action chains. This is basically the same as node graph in Grasshopper, but it's more linear and more simple. And when we started working on Spellshape, we were discussing various file formats, for example, in 3D. And there are so many of them in 3D world, and they are so different. This one is shown here is an OBJ file. So this is a box in Blender, and this is a text file that you can read, you can open it, and you can read, and you can fine-tune large language model to output files like this. So it's just a box, but then you can have a car, for example, and you will have an OBJ file for a car. And if you have a million of such files, you can fine-tune a model to output anything you want. This seems pretty straightforward, but it has limits because even for a simple cube, you have a lot of data here and you have a lot of numbers. And as I said before, large language models are like not that efficient at understanding these numbers. You can easily miss a minus here, for example, or add it somewhere else, and then the whole vertex is moved in a different position, and the model is not that solid as it is supposed to be. So this error can appear anywhere. So this is not very AI-friendly file formats. The same thing with GLB, for example. GLB file format, they have a great logic inside, a scene graph that lets you decompose scene into different objects, different groups, and they have this kind of a nested graph inside them. This is a great idea, but this is also a very complex file format for AI to generate from scratch because it has some binary inside and it's not that predictable and easy to do. So it appears that there are many file formats for 3D generation, but none of them are AI friendly. And when we started working on Spellshape, we ended up using JSON and this simple way to describe anything. So JSON is AI friendly because it has a list of objects, they have keys and some parameters inside, and humans also can read them and edit them. And this was the initial Spellshape version that we launched, I would say, I don't know, August or September 2025. This is the prompt that I got there, and the result that I got there: a rover robot, and some objects appeared in the scene. That was like October. The same prompt, but this is early April, March this year, so not so long ago. This is the same prompt, and what we get here is a rover decomposed into its parts, like, for example, wheels, the body, and then some camera assembly on top of this. Sometimes the model forgets about wheels, sometimes the model forgets to properly position parts and has some gaps. But when we split this reasoning for large language model from deciding, for example, if you ask it to write a code to generate the rover, it will have to reason about the parts it has to output, their position in space, some coding problems related. So basically, large language model is trying to understand what to build and how to build it. And when we are asking it to output a modeling brief, it basically, we're asking it to output only what to build. And how is the completely procedural question. And with this division of responsibilities, let's say, we can easily understand what is going wrong. So here, for example, I understand that the library of tools that we provide to the model is not perfect, and the model cannot express itself completely. It cannot describe the rover in a proper way. So this is the version that we're going to use today. The same prompt, rover robot, but what you can see here is that it has the necessary amount of wheels, which is a super successful thing to have. It has the body of the rover, and the body is created with an extrude tool and has some rounded corners here and there. The camera module has camera lens on top of it. It has a solar panel, and it has an antenna with a nice sphere on top, looking like a dog tail. But this thing is kind of a vision that large language model has for this rover robot. And let's compare this to some other tools. So if we can go from the thing here that we now have a better tools for large language model to use to properly express what rover robot is, and to produce a proper 3D model. And the better tools we have, and the more we understand about the reasoning inside large language model, the more detailed models we can produce. So for example, we could have, right now it all goes into stages, I would say. Stage one is to decide how many objects are in the scene and how are they related to each other. And stage two, for every object, we ask large language model to output a description how to model this object, given the library that we have. And we could, for example, decompose each object into groups the way we do it now, and then reason separately about each group. That way, large language model can produce more details and create a more detailed 3D model. And this is kind of a next step for us to try here. So the final goal is to produce something like this. When you see this photo, for example, of a real rover robot, you can understand that there are so many details, so many small elements. And if you think about it, can large language model describe you properly what kind of parts are needed for this camera to work, for example? Of course it can, especially if it can go and Google something online. You will get a super detailed description, and it can even have some, I don't know, access to some information that is not available online with your own databases, for example, and you can use this information to reason about parts and 3D models and so on. So I think it's really possible with large language model to output the super detailed models like this. A few other tools I wanted to show. The same prompt, a rover robot, there is a tool named Kadam, for example. There is a company named Adam, and they have a tool named Kadam, which is open source and free to use with some limits. And they are building on top of OpenSCAD for programming language. So the same prompt, the same model, GPT 5.4, but output looks like this. And this, I think, what makes tools important, because sometimes probably even that large language models are great at code, they're still greater at semantics, and they can express more in simple words than in code. And another example here, same tool, same prompt, but a different model, Gemini 3.1. Here it is. Here it is. You can see that the 3D model is a bit different. Will it load? Yeah, okay. Some things are better, some things are not, but basically the camera module here is a bit different. Yeah, if we look at the GPT 5.4 rover robot here, it's kind of a cartoon character. It has some eyes. It almost has a smile, some antenna on top of it. It's funny. And this thing here is more technical, I would say. And I think this is the personality behind the models, the way they are trained, and the way the data they have, how they were trained on this data, how they operate on this data, and so on. And it's funny to see these different outcomes with the same tools, just using different models. And another project I'd like to tell you about, the project is called ForgeCAD, and it's also using large language model to generate 3D, and it generates 3D using JavaScript, TypeScript models. It's also open source. You can find it online on GitHub, and it's used to produce various objects. Yeah, and another thing is called FluidCAD. It also uses JavaScript to create 3D models, but it's not AI generated. You have to type it by yourself. So, okay, for today, James suggested to select this site as a test site, Blackrock Historic Bath. It's in Ireland, in Dublin. It's somewhat a bit destroyed right now, I'd say. Don't know a lot about the history of the place, but I'm sure James will cover it in details. And let's try to create something in Spellshape, and let's try to see the limits here. So if you just follow the link in the Notion, you will end up on this page. The setup is rather primitive, I would say. There is nothing so specific about it. So it's a side panel and a 3D space, nothing more. On the side panel, you have different tabs. Each tab contains its own data. And since it's all work in progress, things may change with time. Yep, thank you, James. In chat, you have different prompt guides, like what to include in your prompt, what you should not include in your prompt. We'll see if it works. And some sample prompts. So let's start with, also you can choose different models. Right now we have 5 of them provided by different companies, 2 from OpenAI and 3 open source models provided by Together AI company. Sometimes things may break, not on my behalf, but because there is some limits on the side of the model providers. Ideally, I would say probably the future we are going to is that softwares like this will run locally with local models. So instead of using cloud-based models, you will use your own model running on your own computer, and this thing will be completely local. For example, the new Gemma 4 model, everybody is saying that it's a super model. Haven't tried this yet, but we are trying to build Spellshape as model agnostic as possible, because when you, for example, if we go again and compare it to large language models generating code, that way you rely on the model, heavily rely on the model, because you rely on the quality of the code it outputs. When we try to let the model only describe what the object is, why we are less dependent on the type of the model. And of course, any large language model know what a chair is. And of course, it can describe you a chair. The thing here is to make it describe a chair in a specific way that you can use later to create a geometry with this. So let's start with the first prompt, a tower as a 10 by 10 box twisted with an angle. Just hit generate button and hope that this works. So as I mentioned earlier, what's happening behind the scenes is that there is a large language model that gets this prompt and tries to understand how many objects at all you want to generate. Ideally, it will understand that all you want is a single tower in this scene, and this tower should be a box. And it should be a twisted box. So it's a simple primitive form and then a deformer added to it. So I think I've not mentioned this, but any object in the scene, any part, can be presented as a primitive, a box, a sphere, a plane, or something else, or it can be a primitive and a deformer. For example, like in our case, a box and a twist, or it can be a simulation, something just simulated. And so instead of creating a box, it will simulate something reminding a box. And there are different types of simulations available. I will talk about them in a moment. And sometimes things may not work with 5.4. Sometimes they work. If it doesn't run, we'll see an error here, and then we'll try with a different model. It doesn't matter. It retries for several times, for 3 times, with some limits. So basically, if it fails, it will take about a couple of minutes to fail completely, and then you'll see an error that, sorry, I could not generate your 3D. And we'll start from scratch. Do we need a break, by the way? Or it's okay to go further?
We'll definitely be having a break between the ComfyUI and the Spellshape. I don't know how many breaks we need.
Okay. All right, we'll make this in a more competitive way. We'll try to open a second tab. All right, select a different model and go with the same prompt. And we'll see. Should not take that long. Okay, network error. Network is not on my side, definitely. Now you see why this still works. Progress. Okay, if it doesn't work with AI for some reason that I don't know why, we will still be able to assemble everything manually. It's not a problem. Okay. At least it works for somebody. Well, okay. Let's keep this running in the background. If it fails, it fails. I don't know the reason. I'll figure this out later. Anyway, this is how chat feature is supposed to work. So when you have the model, you will end up in adjust tab, and you will have all your actions available there as a list. If we have nothing from the model, you can click add object and you will have some setups already available for you. So as I said, every object is decomposed into groups, and groups are decomposed into subgroups or parts and so on. So when you want to create something, you need to have these actions for each part. For example, you can click add part action and select anything here, like generate the box, and you have a box in the scene. Okay, fail to fetch here, still running here. I think this probably on my end some issues here. I'm not sure. And so now I have a box. I can click on this generate box action here. I have some params like the amount of segments for this box, the width, the height, the depth. So I want it to be, let's say, 10 by 10, and the height of the box should be 30. So I can adjust these params. I can adjust color, I think, as well. Yes. I can set materials, and if LLM creates this description, again, network error, there's something happening on my side. I'm not sure about what is going on. Okay. And you have this little plus button here. You can add some more actions to your part. So for example, I wanted a twisted tower, so I need a twist deformer that I will add to my tower. Let me hide the box. So now we can see that the twist is applied, but the box is very low poly, so the twist doesn't look great. So I need to increase the amount of segments, and now I have a twisted box. I can control the angle of the twist, making it less twisted. I can control the axis of the twist. Right now it's vertical. I think if I make it X twist, then it will be deformed like this. But you get the logic. It's supposed to be simple. And it's supposed to be produced by a large language model, which is not working right now. Don't know. I don't know. I think it's something on my side for some reason. But anyways, let's keep trying. So yeah, thanks for sharing the screenshot. And you have some other controls here. For example, scene graph code is the logic the model outputs for the whole scene. It has a description of every object in the scene, some parameters, variables it uses, color setups, and so on. It also, if it's produced by a large language model, you can read the reasoning behind this. So you will get some hints saying that I'm creating a box because the user asked for a box in his prompt. I'm creating a twist deformer because the user asked for a twisted box, and so on. So it basically has a list of tools to operate on. It selects proper tools and combines them into action chains, kind of a linear thinking process, how to get the form that you have requested. And we have these eye icons to turn and off different actions. Sometimes when the model generates something, it's hard to understand what if you have, for example, multiple objects generated in your scene. Some are twisted, some are not. Like here in this twisted box example, we have initial box that is not twisted, and we have a twisted box also. And sometimes for models, it's hard to understand which actions should be kept visible, which are not. And it's also happening procedurally inside. So basically, if you generate something, make sure you look through this action chain and ensure that all necessary actions are visible in your 3D scene. That way, you do not end up with a rover, for example, without an antenna in your scene, but it is generated by a model, just hidden. So make sure you see something what is visible and what is not. And then, for example, I want to add a facade here. I could ask large language model to add a glass facade pattern, for example, as a second prompt in my chat UI. But since we're waiting for so long right now, let's do it manually. So I have a facade agent simulation here. This is a simple tool that grabs the form that was created before and applies a different logic to it. If you have some materials set up in your scene, you could select those materials here in the drop-down menus, but right now we have no materials, so it basically uses these colors and glass opacity property that is mentioned in this UI, set up in this UI. And you can see that right now we have a tower with checkerboard pattern. If we it depends on the twist. So if the tower is not twisted, the pattern is rather linear, as mentioned here in the pattern section. So you can see W and G written here. That means wall, glass, wall, glass, wall, glass, wall, glass, and so on. You could also have a V mentioned here, which is void. So wall, glass, void, wall, glass, void, and that's how you design some patterns. You can, of course, explore different options, just adding new characters in a different way, generating something. If you add a twist again, probably the logic would be a bit different. So yeah, you can, but maybe not. I don't know. And if you create, so for example, let me remove the twist angle completely. Let me go back to W and G pattern. If I add a straight vertical line, I'm not sure how this is called, and then I add this vertical line kind of separates floors. So now we have a pattern that is separated by floors. So I have a wall glass pattern on the first floor, a glass wall pattern on the second floor, and then it repeats. And the amount of floors in my tower right now is controlled by the height segment. So if I say height segments 20, I will have more floors. I can also increase the height of the tower and so on. And the large language model can control all these setups. Fail to fetch, network error, fail to fetch. I don't know. Really. I'm not sure what's going on. Anyways, if this works for you, basically this is the pipeline in the workflow, so it doesn't matter. And I can also have columns control here. Columns basically let me split something into a more I don't know, creative way. So if you play around with columns and add some numbers there, you will end up with something not that straightforward. And if you add the rotation angle, you will start getting something creative as well. So let's say we ended up with something like that. We have a tower, it twists a bit, and we have some kind of facade pattern on top of it. What else can we do here? First of all, the tools section has all the tools that are available to large language model to select from. Some of them are constructors and simple generators like generate box, generate sphere, extrude to create more complex forms, bridge along, generate arch, mirror, and so on. A list of deformers that will twist and bend your geometry. Extractor, let's try implement it further. Merge group, if you want to combine different parts into one group, coherent, some simulations. Yeah, for patterns, you can have any combinations of walls and glass. In WG, just type WG, and you can also have V for void if you want an empty space in your facade, and then some columns at some numbers, and that's how it will operate. In scene section, we have a basic scene description used for image generation. When you provide a prompt, a smaller model will take this prompt and try to extract some scene parameters out of this, like style that you want to create, some era, probably period, some mood, a topic, or kind of an object you're trying to create, color palette based on your prompt, environment setups, camera angle, I don't know, weather, and stuff like that, and overall vibe and scene description. This should appear here, unless we have some API problems like we have now. Then you can export your 3D objects in GLB and OBJ format. Just click this button and the whole scene will be exported. I think it will be exported with all the objects that were created. So in our case, it will not export the final tower, the twisted and was a facade. It will also export the initial box, the twisted box, and then this third object facade pattern. You can have some setups here, like background color, for example, grid and axis, a wireframe, if you want to see the exact geometry. And this is a great difference from diffusion models that we're gonna cover later. Try to generate a simple box with a diffusion model, where you will end up with 1 million of polygons. And here a box is a box, it's a code, and you have a decent amount of polygons and vertices. But since we're working online in the web, everything is triangle. You cannot have quads here because this is the way web operates. For render modes, we can have a black and white output. We can have some overlays with basic colors and then some black contours here. Controlling outline colors. Yeah, we can have red outlines, for example. I don't know why would you need this, but probably or something. Light controls, camera controls, fog. Yes, we can have some fog. Okay, let's not add fog. And the next tab is render. This is basically a tab that creates your render image. Then nothing fancy about this. Will this work? I don't know. So you can click preview screenshot and you will see that this grabs the screenshot of your scene. You can type in some prompt here, for example, and we have Nano Banana Pro generating images based on the screenshots here. So the logic is like this. You create a screenshot and then it gets to Nano Banana Pro model with the prompt that you created here. You can click AI prompt and it will generate a prompt for you based on the scene description and the prompt you provided initially. But right now, let's try to do this manually and let's try to make it, I don't know, a graphic poster of a modern tower in New York. Clear sky in the background, Y2K style, something like that. Ideally, you would add something like keep initial composition and click generate image. If it starts generating, it's great. If there is an error appearing here, just you can try pressing generate image again, and it should work. Since Nano Banana Pro takes some time to generate, oh, the image generation worked. Okay, I don't know, something strange happening here, but voila, you have New York City Y2K tower. I'm not that good at prompting Nano Banana models. To be honest, I would say that the first version of Nano Banana worked better for me than the later versions like Pro and the second Nano Banana. Probably James will be able to explain what is happening here, but most of the time it can skip the composition request completely and generate a different angle, for example. I was not asking for any text in the prompt and it added some text here. At least it made no mistakes. This is great. So the next thing after you have an image, you can generate a video. So you can type something like, I don't know, anything for camera controls. Nice. Cinematic camera movement. I don't know, 2 words. That's our. And since we have this image, we can click generate video. And the model we use here is Seedance, some version of a Seedance model. I don't remember exactly at the moment. And it will generate, I think, 5-second video, but it will take some time, definitely. So, yeah, basically grabs an image generated by Nano Banana and creates it into, turns it into a video. regarding the question in the chat, we have three characters here available: W, G, and V for facade pattern generation. V is short for void, and then you can have something like this: WG, vertical line, GW, and WWG, then vertical line, GGW, something like that. Okay. Or you can have something like wall, void, glass, wall, something like that. And we have a video. Voila. Oh, it keeps the text. Cool. All right, and you have download buttons, so you can download all the generated images and videos. We do not keep them anywhere online in the cloud. There is no database behind this platform yet, so you don't have to register, you don't have to create accounts, you cannot save your projects or wherever, somewhere in the cloud. I do not even know what kind of prompts you are trying to use there. So if you could share your prompt, initial intent, and output as a screenshot or in whatever format suits you, that would be a great help for me, because I would better understand what do you want to use this platform for, and how I can help you here, what kind of tools I could build to help you. Okay, let's this is the twisted tower, and in my presentation I have this as a first image, and I forgot to tell you that in scene tab you can also add a background image. So if you have a background color option and then you have a background image, if you click plus, I have an image prepared here for this webinar, and well, probably this is not the best option to position tower here, or not the best image, but these are the screenshots that I made from Google Maps. So I need to remove the grid, remove the axis, and right now in render, if I click preview screenshot, you will see that now my screenshot has the 3D model here and the background. And I would use the prompt like this one in my presentation, make this collage into a photo of a bathhouse in Dublin, something like that. So let's try one more time. Let me try Robert here. Probably it will work, but anyways, let me start from scratch and show you a different example. The second prompt here is a pavilion as a 1x1 plane with growth. What this thing should do is create a plane and apply a simulation to it, a differential growth simulation. But let me just repeat this manually. Since I'm having some connectivity issues. So what you will end up with is a plane, simple plane. A plane should have width 1 and height 1, one width segments, one height segments. And if you then add in differential surface growth simulation, you will have something like this. Let me remove the axis, the grid. Let me also, the initial plane is down there. You can see it in the viewport. Let me turn it off. So this is a differential growth simulation applied to a plane. The simulation is trying to grow the plane, and then it has some also collision params, and with every generation it calculates the next movement vector and tries to avoid other parts of this geometry, and in the end you end up with something like this. you can control this simulation with the number of iterations. So you can start simple, like 50 iterations, for example. You will get something like this. You have controls for maximum edge length, so how long each edge can get. The minimum edge length, how small it can get. Repulsion radius is basically how far they get pushed with each generation. Repulsion strength, how strong is this repulsion thing applied to vertices and edges. Spring stiffness also helps you control the way the whole thing operates. Initial jitter, if you add some jitter params, you will get more irregular forms, especially with the more generations, more iterations here. You will add something like, you will have something like this here. And I recommend starting with 1x1 plane and one segments. But basically, if you have more segments, it seems like it's getting more chaotic as a geometry, as an output. And you can also add subdivision surface later on to make everything more smooth, and you will get a form like that, something like that. Again, if I make less segments initially, probably less iterations as below, something like that. If I remove the jitter, keep it as 0, I will have a fully symmetrical form that grows starting from my plane. I can use various initial geometries, plane, box, cylinder, whatever, and then apply this simulation as well. This will work too. And let's add some more generations, iterations, probably something like this. And after we have a subdivision surface, let's try to add a thing called split mesh to topology strip meshes. What this thing does is basically grabs the geometry you provided and splits it into strips. So if we export this model, we will get not a single mesh, but a group of mesh strips. I'm not sure if color controls work here. Has boundary gradient. Okay, if I remove this boundary gradient, will it work? No, it doesn't work. Okay, so it has to have a gradient. Okay, for now. Basically, the gradient is controlled with the hex colors. So any color in a hex format here, and probably that will do as well. Will this work? Yes. No, red will not work. Okay. Something like this. And the more iterations we have in subdivision, the more strips we have, the more detailed gradient is here, and so on. But basically, with web tools, you're very limited with the amount of polygons you can have. We are not running this in Rhine or Grasshopper. We are running it in a browser, and browsers are very limited in terms of how detailed geometry you can get. So make sure you don't make that much of subdivision iterations here, or just keep in mind that the more polygons you have, the more opportunity that your browser will crash. So let's try to, I don't know, should we render this as well? Let's try to add background image with the site. Okay, will this work? Okay, okay. Let me put my pavilion somewhere here. Find the perfect view, something like this. Let's grab the prompt from the presentation, paste it here into a photo, house pavilion, white porcelain glazed, concrete. So this thing, let it be a concrete shell with some local patterns. Keep initial composition. I don't know, probably we could try some kind of graphic style here, like oil painting style, something like that. I click generate image. I can see the screenshot. Right now, basically the screenshot is rectangular and the output is square image because we don't have controls for the frame aspect ratio, but it's totally doable just because I'm always busy with the reasoning behind the LLMs, so I don't have that much time for UI. Okay, now we have an oil painting with some porcelain sculpture here. And the thing here is that, of course, we could generate something like that from scratch using image generation models, but that way we don't have control of the geometry. Here we fully control the geometry, and the geometry is the basic input for the image generation. And one thing I can show you also. One thing I can show you also is another project, Intangible AI. I think, oh, yes. These guys are also doing 3D controls to image generation, to video generation, and they are mostly focusing on a product for movie directors, for example. So using this tool, they have a library of predefined assets. They have 6,000 assets in their library, and you compose each scene out of ready-made assets. So with Spellshape, if the models work, you get a logic for every model that you can control instead of the ready-made asset. But this is also a nice thing to see. So they use 3D models and 3D scenes to control the output, basically the same way we do it now in Spellshape. So yeah, you can see that you can add some objects here and there, and then use it to visualize. Basically, this is the workflow and the pipeline with the 3D. Okay. Let's try something different. Okay, this one is done. This thing here, the voxel style. So if you ask for, if you go to tools and you go to simulation, and every tool has keywords described here. So if you include these keywords in your prompt, this will trigger this exact simulation. That way you have more control and the output is more predictable. So for example, I have a cellular automata simulation here, which creates some kind of voxel style outputs. And I have additive cellular automata. These are different things. Let's start from scratch. I will go to adjust, I will create an object, I will add the first part, and I will use additive cellular automata. And this will create something like this. So just some boxes. And in controls, you can have the grid size control. For example, the grid is always square. The number of generations, the cell size. So cell is 2 by 2, and the floor height is 3 meters. So each voxel is 2 by 2 by 3 meters high. Initial seed, you can just type different numbers and you will see that the simulation outputs something different each time. And initial density, I'm not sure. Okay. It has some weight here. So 04. So that way you can easily generate some voxel-like structures, and large language model is able to reason about some voxel-like structures and their DV style, their Kingel style, something like that, using simulations. And I see a great opportunity here, combining procedural design with AI kind of controlled logic, because seems like a very interesting outcome. And I was recently talking to a man who created a procedural design engine for Unreal Engine. He spent like years working for Unreal Engine, and he was responsible for designing their procedural level generation tools and so on. And I reached out to him talking about Spellshape and all this concept that large language models could operate on top of procedural logic and so on. And he replied me that, yeah, I also tried large language model to 3D and it was a disaster. And probably your approach with ready-made tools you could operate on should work better. So this whole area is very experimental and very new, and it's hard to expect something like I don't know, really working as expected, but there are a lot of attempts in this direction, and I think that LLMs already know everything. It's just the way to find the proper way to extract this knowledge and to implement this to generate 3D. This is the process somebody should track. So some rule presets, you can provide custom rules in the scene graph code, I guess. Generation, color gradient. Yes, in the scene graph, you can create rules with just mentioning different numbers in survive and born. If you know how cellular automata works as a simulation, you will definitely understand this. If you don't know, basically it's a grid-based system, and every cell looks around on its neighbors, and based on this, it can have two states, either alive or dead. Every iteration, it looks around on its neighbors, and if neighbors are alive or dead, it takes makes a decision on whether this exact cell will be alive or dead in the next iteration. And these rules are very simple. The idea is very simple, yet it can provide very complex outputs with various creative opportunities here. Mostly cellular automatas are used to generate, they're used to generate different things like coral growth structures, some fluid simulations as well. In biology, they're used to simulate viruses, for example. So this is a great topic for a separate webinar, and I really love this simulation. and solar automated as a topic, and I constantly talk about them. And also there are some gradient presets here and there. Probably we have too much generation for our use case with the public paths, but maybe something like this will work. Let's try initial density a bit lower, O2, probably something like this. So let me add a scene background here. Okay, let me find a good perspective. Okay, hide this, hide that. Probably a different gradient should work. Ocean, sunset. Okay. Oh, right, that will be sense. Okay, let's try the same prompt. Maybe wooden voxel style sculptures.
I wonder if the prompt Ricardo Bovil would work well with this.
Which one?
I'll type it. He's an architect from Barcelona.
Oh, yes.
With the red wall.
But then it's not wooden.
No, it's not, oh yeah, it's not wooden, but yeah.
Let's try wooden Ricardo field. We'll see where it takes us. Okay, so here is my issue with Nano Banana. I grabbed my image and I would put something completely different. I don't know. Probably prompt issues. Probably I should say something else. Maybe the thing is the graphic output, black and white graphic style. Maybe this will work. Okay, now we have no error. Just click generate image again. Yeah, it already has this align keep initial composition. Maybe it should be more descriptive, like like the one you're suggesting. Okay, black and white graphic style. It's better now, I think. Not what I expected, but it's black and white. Okay. So yeah. And the final, I think, approach here. This one. This is also, if you type something like, we have another simulation here called trace agents. Let's let me try just remove this thing here, add a different action, trace agents. All right, this may not work that great with this image because I forgot to add ways to change the color of the lines, but I can change it to tube. And all right, and I need a material. I need to make less agents, let's say 20. Let me add a material, material 1, let it be white somewhat. And if I add this material here, material 1. Yes, now it's white. It's still not that visible, but let's make it, I don't know, red. Okay, this is better. So what it does, it creates a list of agents and kind of runs them in a space using some vector field, and they follow these vector field directions, creating this smooth and turbulent forms and shapes. And you can control this using field scale. The larger number here, the more curvy the lines as output, the less the number, the smoother they are. You can have different count. Of course, lines render better than tubes, but it's hard to render them. Let's try removing the background. If I remove the background here, okay, now the lines are visible and it's easier to have more of them, like 220, and you can see that they create this kind of structures. And this is basically this could be used to create something like, I don't know, inspired by a flock of birds or some wind flows, stuff like that. First thing, if I create an object first, like for example, I don't know, let's try creating a plane, and let's add a deformer to this plane. For example, solar noise here, and let's make, well, let's make this plane look something like this. And then we add these trace agents, and we provide every action is called something by default, and every action has inputs. So if we input solar noise into our trace agents, and we have surface mode on dash surface. Yeah, now they are running using the geometry as an input, and they kind of following the form of geometry, not ideally as they jump back and forth, but still okay. Why is that happening? All right, something happened. And all right, I can remove it now. I'll start from scratch. So you got the idea, I think, that you basically add a plane, you add a noise deformer. You bump up some segments for the noise to work properly. You get an output like that, and then you apply trace agent. You can also apply facade agent, but like whatever, experimenting with different deformers. And surface mode on surface. On surface, starting with O. Okay, and let's try to have more of them. Maybe more steps as well, and then hide the noise surface. Not that exactly following the surface, but still something. And we can try to render this as well. Let's hide some plane. Let's hide grid and axis controls. And I think it's gonna be very hard for image generation model, but let's say I want this to be a wooden pavilion in a park, steam band wood, keep background position. Will that work? I don't know. Let's try. Now we'll try generating using large language model as well. Okay. And now we have something like this, somewhat reminding the geometry, but not exactly like what we had. And all right, I think this is basically it. This one image is the image is in my presentation. If you have large language models working on your side, feel free to experiment with different prompts. And this example is, I think it's hard for a large language model because it requires, it's a complex assembly part, and it requires to think about a lot of different objects assembled together in a coherent composition. And this is a challenge for large language model. This actually a different composition produced by Nana Banana based on the input I provided, which is not relevant to the input I provided, but still I decided to keep it. You can, instead of prompting something like a tower as a box twisted with an angle, blah, 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 you can just try something like an opera house, a bathhouse, and I was experimenting with this before this webinar, and you will get an assembly of different volumes. I think it will be boxes basically, because large language models, they always try to find the safest output possible. So if you wanted to go crazy and invent something, it won't unless you ask it to do this. So it's the more certain the guide you provide, the better the output. If you just ask it for an opera house, it will not come up with something, I don't know, Frank Gehry style, for example. If you want to have that creative output, you have to specifically ask for this in your prompt and provide the guidance how to achieve this. Like, for example, use many boxes, rotate them, scatter them, twist them, deform them, whatever. You can just take a look at the tools section and experiment with something. And let's see where it goes. From there, okay, I got a rover. Okay, finally, I got it working. I can show you the real life process. Finally, so if you generate something, in chat, you will have this message that initially you send, and then you have some planner details with some reasoning behind this. So it says the prompt describes a single complex object, a rover robot. It should be represented as a one primary object with internal functional groups such as body, wheels, camera, solar panel, and antenna. So we have two solar panels here. Amazing. And see, this is what I was talking about. These solar panels are located on the horizontal cylinders instead of vertical cylinders. And it's totally fine for large language model to output something like that. This may be an issue with my procedural fixes afterwards, but you see the camera module that has no lens and has no post here or mast, whatever you call it. If you go to the action chain, you will see that the camera mast is not turned on and the camera lens is not turned on. So now we have a robot, a rover robot with two solar panels and one camera mast. And ideally, I would say a next step would try to maybe add a second generation iteration based on these parts and these groups, kind of reason separately about each part and each group, and maybe large language model will create a more detailed camera lens here and more detailed output for solar panels, wheels, and so on. Well, you know that rovers are really detailed, and it's interesting to see how far we can push this logic to generate more detailed outcomes and more detailed outputs. And since this was generated by a large language model, all the materials are set up here. Each material has its own description. You can try and generate a texture. So for example, I have this blue material here, painted metal. I can click generate texture. It will use Flux-Schnell model under the hood to generate a texture. And okay, now we need to adjust some vision tools here and there. Okay. Now I need to see this. Now I need to see this. And now I need to see. Oh, we need to see this. We need to see this. We need to see. I think this is all we need to see. So now we see the texture is applied. It doesn't completely understand what kind of material should go where. So for example, we have this material metallic. What kind of material is this? Painted metal for camera. Of course, camera lens is not going to be painted metal. It has should have some glass. But for the body, it's okay. And of course, there are issues with texturing because you have to UV unwrap every object and generate the texture properly, or adjust the UV unwrapping process, and it's not gonna get there yet. I mean, the large language model will not be able to do this unless we provide it with tools and ways to reason about this and think about this. We can add visual language model, for example, as a check point here, so that we generated something, we grab the screenshot of this, send it back to visual model, get some output, some feedback, and regenerate the scene again. This is also possible. It's not applied yet. And you can see a lot of variables here, like body width, body height, body depth. Let me increase the body height, for example, and I need to fix this visibility bugs, but basically, so now my body is that high compared to it was before. So the whole model here is parametric. The logic is parametric. You control all this logic and you keep everything. You control the process. That's why I think it's good, and I think it's worth continue working on this. And you can export everything. If you go to scene, you can find download GLB and download OBJ. And I think that's a wrap. If you this demo will continue working for some time. I don't know, since I'm the one paying for the credits used for generation, image generation, and stuff like that. It will work for some time. I don't know for how long. If you could share your tries, your outputs, what you wanted to create, what was created, what was not created perfectly, that would be great. Please reach out in Instagram or LinkedIn. And if you want to somehow help and support Spellshape as a project, maybe you're indie developer, game designer, maybe you're an architectural studio, and you see that this tool may fit into your workflow and your pipeline, please do reach out, because that way I have more understanding what exactly we can build with Spellshape, because right now we have the technology, we have the possibilities of large language models in 3D generation. And my idea is that it's up to us to really form this into a product everybody needs. Right now, I'm balancing two different options, basically. Either go completely open source and then who supports this project, who pays for the generation and so on. Go closed source with SaaS-based subscriptions and stuff like that. And then it seems that we have less people who could use this project since it's going to be a paid version, but right now it's free for everybody. So enjoy. And thank you for your time today. And I don't know why this thing was freezing for so long, but finally it worked for me. And I'm happy I could show you the whole pipeline. And James will continue.
That was fantastic. Really great
Yeah,
work.
thank you.
Should we take a break now? I guess it's probably the obvious time to take a break. And maybe we come back at 15 minutes past the hour, um, which is like
Sounds
7 minutes.
good.
So, yeah. So whatever time zone you're in.
See you guys.
I'm back if people are listening in. Thanks for the thumbs up. I don't know if people are there otherwise. All right, I'm just going to go ahead and share my screen and hopefully people will make their way back. Okay, so I'm going to talk about collage in general, as Stepan mentioned earlier, and then we'll go on to talk about image generation and ComfyUI and installation and stuff. And I don't know if everyone's going to get it working today because it's a lot to download, but I think kind of get the process going. If you know it already, maybe you know a little already, or it's new, but either way, kind of there'll be instructions that will remain on the internet to get it done today or later. So starting with collage, I kind of watched this one lecture from this Yuval Edgar, professor at Oxford, and giving a lecture at the Courtauld Institute of Art in London, and said, you know, that collage is often commonly defined as the cutting and pasting of images that do not belong to us. And I think in that sense, even though that was not a lecture that had anything to do with AI, it sort of resonates with some of the kind of conversations that are around AI and how AI images are trained and the relationship 100 years ago, or slightly longer than 100 years ago, of collage being a derivative work as opposed to a sort of fully original work, and the kind of questions of authorship that sort of surrounded collage that continue to surround the idea of AA generated images today. He included this quote, which I found very interesting, about edges involving extremes. Edges are borders. Edges are very much about identity, about who you are. Crossing a border is not a simple thing. And sort of relates to that a lot of collages are about the combination of multiple sources on a single canvas, which then the edges become the sort of highlights of the work that sort of show where the kind of importance matters. And in that sense, if you have two derivative works, I was thinking of the front cover of Content by OMA, which has George W. Bush and a McDonald's hat on top of his head, inverted. And each of those images, individual to themselves, do not suggest kind of stupidity, but when you put them together, it's the combination that then carries a new message. And in that sense, collage is, you know, can be about the edges or the combination and sequence of events, and therefore the derivative work often kind of changes something about it. Another quote there that comes in, that collage can only exist in what Walter Benjamin calls the age of mechanical reproduction, in the sense that nobody was ripping up 18th century paintings to do collage. It was the sort of era of magazines and newspapers and mass medium that then gave the freedom and the cheapness in order to create these new works of art through affordable means. And that was sort of a really important aspect to how collages are produced. That's not to say that collages didn't exist at the point. In Japan, they go back as far as the 10th century and throughout the kind of Middle East and the sort of Levantine area. But the word comes from the French word to glue, with Picasso and Braque around the early part of the 20th century. Impossible combinations, loose elements that don't seem to connect to each other. I think, you know, when you get onto kind of Magritte's paintings, that there's not necessarily a face underneath um, the apple, but it's sort of a painting to be simulating the idea that it is two layers when actually it's painted as one layer. So it's sort of a new kind of how this medium kind of evolved. And looking towards American artist Tristan Eaton, more known for the kind of platform art or toy art movement, but also does these kind of street works, which kind of have the sort of parent whole of an image, but then all these kind of layers inside that kind of tell various stories around the kind of overall image. From my friend Gavin from school and his Instagram account, Morning Assembly, just showing that collage is a very easy way to kind of create scale and distort scale from reality by just making the sort of image layers of different sizes. And hopefully you can hear this. Maybe some thumbs up to make sure, but So just a short video to sort of talk about, collage and then montage as a kind of sometimes used to mean the same thing, but sort of more interested in the sequence of events, often in video. And here's another one that's just really short. A really good food show when it was on Vice magazine or Vice YouTube from back in the day.
Lottie Dottie, we like to party. We don't cause trouble. We don't bother nobody. Lottie Dottie, we like to party.
These are, two songs, one from 1985, one from 2013. And in TED Talk from a long time back, Mark Ronson, How Sampling Transformed Music, kind of told the story of how this song is one of the top 5 most sampled works of all time and is very much got all these people making derivative works from it. So you get Notorious B.I.G., Ricky Ricky Can't You See, Somehow Your Words Just Hypnotize Me, to the same sort of sound or tune of La Di Da Di We Like to Party. And then you have so many variations of it. So Fun Loving Criminals do Lottie Dottie, Free John Gotti, a sort of famous mobster of New York who was arrested. And in that sense, we have this kind of range of activities that all kind of go around the idea of derivative works. And not to go through all of them individually, but interesting that a quotation is also kind of a derivative work, but it's sort of giving attribute to somebody else, but it's still kind of using the Control C and the Control V of a computer to copy something, but we have different opinions on it. And AI is sort of now, I think, added to this list, kind of coming from a history of collage and how that works with authorship and who owns what and how images are created. Right backward. So in architecture, you've got the book from 1978, Collage City, that sort of asked cities not to be planned from one perspective, but asked multiple perspectives to be adjacent to each other, classical architecture to be beside modern architecture, and kind of contemporary architecture, and everything just to basically become a collage. Then you have kind of Koolhaas and Madeline Vrieskop in the City of Captive Love that appeared in Delirious New York, I think. And it's about programmatic collage. So the idea that different ideas of program would be put together each other in some sort of weird combination that then would have interesting effects architecturally. And this is sort of about different fantasies of architecture being placed in a very New York City-like grid that you could go from one utopian fantasy to another that might be conflicting with each other or very different. This image was photoshopped or kind of edited in a talk by Renier de Graaf, where it sort of had the logos of corporations, religions, and countries on top of each other to suggest that bigness is now that all these things are just the same and you can kind of go on this grid between things and it's all just one giant collage. Then, of course, just typical collages from OMA, in this case, suggesting that a museum could be adjacent to a swimming pool. And if the exhibit wanted, the artworks from the museum could just be thrown in the water and you could have this sort of underwater scuba experience with sculpture. And this is kind of what is meant by programmatic collage and OMA. And even though this might not be collage in the typical sense, there's a really interesting lecture by Brett Steele, who's the current dean of University of Southern California, on about when the architect puts themselves in the image, the way Mies van der Rohe did, and who's also got a whole bunch of collages around the Barcelona Pavilion. But in this case, the idea that hands of the labor are actually in the image is a sort of form of collage in itself. Tatiana Bilbao from Mexico, looking at ways of life and sort of different ways that people in Mexico are living with just these kind of sketches over the architectural collage image. It's kind of a collage on top of a collage in a sense. And then another quote from Marshall Brown, who wrote a book, The Architecture of Collage. What you see is a collapse of multiple spaces, multiple perspectives, multiple time periods into a single moment. And he kind of talks about that collage is a way that, in a way, other mediums kind of struggle to do this, but collage is a way that we can kind of get that combination. Again, if you look at this image that he produced, that it's about two different kind of architecture types merging on each other and the edges become important again. Then we kind of have collage around more surrealist and sort of fiction. This is from Perry Culper, and there's sort of interesting lectures around his diptych follies. And one of his former students, Eilish Finnegan, who tells a story of kind of being unsettled by bathrooms and maybe the idea that one might slip, and you can kind of tell stories in a way that photorealism struggles to, and you can kind of talk about maybe death and the scared and the fear in a collage in a way that a photorealistic image might be just a bathroom. And it's sort of, you could put a caption on it, but it's a way of telling stories. And that idea of telling stories, I don't know if anyone watched American Gods, but I have this favorite quote from Mr. Ibis, who's based on an Egyptian god of writing and record keeping, that stories are truer than truth. And he goes on while Matt Sweeney is sitting on the couch, who's the Irishman, to explain what that kind of means. But two books, Factory Man, fantastic read for architects. But these are books by Beth Macy. Dopesick's also a book by Beth Macy. And what she does is she combines fact and fiction in that, let's say in the opioid crisis, takes 100 doctors and 100 patients, but combines them into one patient and one doctor, and then keeps the Sackler family in place, and therefore combines the real stories from the Sackler family and their role in the opioid crisis, but just has this one doctor and one patient, which is not necessarily fact, but because it's so hard to go through 100 people's stories, it actually distills the truth in a way in a story that makes a kind of truer sense of what was going on so the majority of people could understand what was going on in the opioid crisis. And that form of storytelling kind of leads to this idea that stories are truer than truth, and how the collage plays a role in storytelling and truth. This is from Manor, a student from last year from EAC, and just exploring other tools, just mentioning one. This is Google Whisk, and sort of a collage where she's put herself into this kind of image and is kind of animated through it to tell a story. Kind of, to me, had a bit of a Ricardo Boville vibe going on, back to that. Collage is online collaboration. This is a famous project from 2005, $1 million homepage in which pixels were sold and earned, I, I can't remember if it was the reselling or the original selling that earned the $1 million, but anyway, a very lucrative project for Alex too, as a young creator, and went on to found cam.com, which I think couldn't be any more opposite than this image. So which is a $2 billion valuation startup. So, and then similarly, Reddit did Our Place, and that kind of had a similar sense of collaborative and collage, and you kind of choose the pixels. And you have this kind of Internetopia by Ben Radford. And that was where Kickstarter backers, and I was one of the 220 backers here, who just put a prompt forward in which he then went over a series of months and illustrated this beautiful image. And the more, I guess, you backed the project, the more pixels you kind of bought. So it was sort of pixels for sale, really. I only bought a small Scottish Fold kitten because my girlfriend at the time, now wife, really liked the Scottish Fold kitten. I've since learned that maybe that breed is really cute, but has a deformity and is kind of suffering. So maybe not the best to promote. Maybe it's regrettable of the times I didn't understand enough about cats at the time. But anyway, it's a really great example of hundreds of people or 200 people putting together their prompts in order to create this kind of larger whole. Floor796.com is a website that's cool to visit, and it's much bigger than this scene here, but it's sort of meme culture that's clickable and in constant animation that is a collage of types in a sort of web interface, in a way that the sort of still image couldn't do. And in the Notion, I kind of added this thing here. I just think it'd be really fun if people had time to sort of submit a quick text prompt. And if we get a bunch of responses, we might make a sort of, or I might make a giant image kind of similar to this, but with everyone's prompts. And that would be really fun if people have just like a short, like 10, 20 word thing, and we can combine different people's interests from different parts of the world and make this big collage image. I think it'd be really fun. So onto image generation. That we have talked about different models already, Nana Banana. I normally talk about like how these models and where these kind of numbers come from and how the file size. I might sort of skip that part other than to say we can see that SDXL is 6.5 gigabyte as a model coming from Stability AI. It's trained on 1024 by 1024 pixels, sort of the default type to feed it. Earlier models by Stability AI or Stick Diffusion were 512 pixels by 512, which maybe didn't give as good of results as this kind of current generation. And it's locally downloadable and fairly open commercially. Coming on to Flux, it's also 1024 by 1024, starts at 12 billion parameters. There's other versions that go higher. There's 23 gigabytes for the FP16 file. And when we speak about these models and you're downloading them, we'll often speak about the floating point size of them. So full precision is FP32. That's a 32-bit number. That is the precision of the model. And we can kind of reduce that, which reduces accuracy, but also massively reduces file size, which then makes it easier to run locally. So reducing Flex 1 to the FP8 version reduces the model size to 12 gigabyte, which is if you have a, let's say, 16 gigabyte GPU, then that's a much sort of easier to fit in size of model. Flux 2, if we kind of go to the fourth one, is 64 gigabytes at FP16. And I'm not sure what the FP32, the full version is, but that would be, very hard to run locally. You would sort of, the Comfy Cloud are using 96 gigabyte GPUs for the subscribers. But locally, nobody's really going to have a 96 gigabyte GPU. So they have this distilled version, sort of coming from the original training, but then reduced. So Flux 2 Klein is a 4 billion parameter model, reduced from 32 billion, coming in at 4 gigabytes at an FP8. So it's a mixed precision or lower precision model of the original. And I think if you're to download one model for this kind of workshop, I think Flux 2 Klein 4 gigabyte FP8 is a very versatile model. It's a very light model. It's probably the one to get if we're just to get one. And then Nano Banana and 2 and 1 are not open, so you can't download them, but you can use them through the API, and you can use API calls through ComfyUI if you want. And you've kind of that choice to mix local and cloud-based generation. Speaking to Stepan's issue earlier on Nano Banana 1 versus Nano Banana 2, Nano Banana 2 is a multimodal model. Nano Banana 1 is a more specialized model, and in that sense, the prompts might actually work in a very different way. And we're going to do this Flux 2 Klein, which is kind of a bit more generalized, but generally older models, even if they're a little bit inferior, if they're more specialized at the task, they sometimes deliver better results, right? And I kind of talk about that a bit later as well. And then just to add, there's other models coming from China that are fantastic. SetImage, especially coming from Tsinghua University in Beijing. Seedream is ByteDance, which is TikTok, and Hanyan have a 3D model that we're not going to use, but is I have downloaded, and it's used their sort of 3D. And if you use ComfyUI Cloud, that's using Hanyan 3D as well. But yeah, so there's different options. And then Midjourney is obviously a closed source paid model from San Francisco, and DALL-E 3 from OpenAI. So kind of explain what a specific model is for. If we take Edward Hopper's Nighthawks 1942, we use a Flux 1 in-painting model that basically I'm going to add a mask. In this case, I've added a very like a paintbrush drawn mask in ComfyUI, which I'll show you. This is a very basic form of mask. And I basically added all these seats, and maybe a little bit inspired by Sherry Turkle's Alone Together, that we're all in this digital social media space and we're all together, but we're all equally alone. This image is kind of maybe an extension of that you have all these people at the bar and they're all alone. That's kind of more of a modern version rather than the 1942 version of one person sitting alone. But this is basically in painting. You're basically drawing masks, giving it a text prompt, and do it. And this is let's say Flux 1 in painting is a 16 gigabyte model. It needs an image, it needs a mask, it needs a text prompt. That 16 gigabyte model then will give you what we just saw. And that model can basically be on your computer, it can be on the internet. It's 16 gigabytes. It could, probably not going to run on your phone. It needs a GPU to run it, but it really could be anywhere. And I think that's one of the points I want to get across, that I think a lot of people maybe don't fully understand that the parts that generate images, that when it's on the cloud and it's kind of somewhere else, it's kind of obscure and maybe it's like super complicated, but it's actually not that complicated. You just need the 16 gigabyte file, the right sort of setup, and it runs anywhere. And then since you don't need to pay, it's kind of like having a bicycle outside and having a grocery store that's 5 minutes a cycle away, and then getting an Uber because you don't know how to use the bicycle. And I think a lot of companies aren't using enough local generation and are paying too much to the cloud because they don't know how much they can actually do locally. The cloud is useful at very, high-end things. You're not going to do video generation locally probably, but it should really be a mixed approach, I think, of local and cloud. So not going to go through this today, but just to show you, if we have the model on our computer and we have this file in Python, nothing else, we've sort of set a prompt that I'm going to input in the terminal. We've set and this is coming from Hugging Face diffusers. If you have the libraries installed, then it asks me basically in the terminal, enter a prompt for Stable Diffusion. I set an astronaut riding a zebra on Mars, and then it just creates the image. There's no interface here. It's just literally Python code, a model, the right folders, and it works. This could be on Hugging Face Spaces, as you know, in the cloud. So in this case, I've taken Evelyn de Morgan's Medea from 1889, Hugging Face Spaces. So this is Hugging Face's GPU, give it a prompt, and basically what outpainting will do is it will usually shrink the image, reduce the weight of the pixels on the kind of border often, then give new pixels. Pixels either have a weight of 0 or 255. 0 is black, 255 is white, it's brightness figure. So these black pixels are basically empty pixels. And then we do the fill and we basically expand to there. Then this is Google Colab, and it's again just another interface, but it's again, you download the model, you give it the right code, you get the results. In this case, I have a sort of more dynamic prompt where I'm taking variables for season, material, tree type, and time of day, and saying generate 10 or 100 or 200 and just keep running, basically making images with random generated prompts. And this would be using Google's GPU. So in that case, they have the option for A100 on a pro membership for $10 a month, or smaller GPU, I think a T4, which is probably going to struggle to run Flux and Flux 2, but might run SDXL. So it's sort of, I think when you do this way, you really learn what your GPU capacity is relative to the images you can generate with that capacity, and you learn the weight, as in the kind of computational weight of what you're actually doing, and not just outsourcing it to the cloud in an inefficient way. So when it comes to Comfy is a sort of node-based interface, very similar to Grasshopper, in which I've created a remote here connection to what's on the left, and I've given it a similar dynamic prompt, and it's a random material, a random topology, building designed by a random architect at time of day with random type of tree out front. And each random list, I've just given a list of like 10 options that it can pick from. So in this case, we have a robotically controlled red brick tower building skyscraper designed by Tadeuando at midday with cherry blossom trees out front. And it probably doesn't do so much with the robotic red brick because Tadeuando maybe cancels that out. But if it had picked a different random architect, maybe the results might have been different. So my ComfyUI folder is massive, and I've got all these different versions downloaded, and often it's like one 11 gigabyte file after another. And this is just the diffusion models folder. There's other folders as well. But you can see at the bottom here, this Flux2 client base 4 billion parameter FP8 model comes in at a very small model, and it's actually one of the most powerful models here. So it's the one I suggest downloading, at least for this session. On installing ComfyUI, I've basically got this page here. I'm going to go through it at the end when I get to the end of the slides, and we'll go through just some of the basics in case people haven't done it already, and see if there's any questions. I can't see the chat when I'm doing this, by the way, but I'll have a look afterwards. I shorten it to a bit.ly link just so it's clear magic models. And at any point after the workshop, any problems installing this or questions on other workflows that might be more diverse than what we're covering here, just message me on either Instagram or LinkedIn, best place to go. So I thought we'd look at first at a 2D workflow. This is another famous collage from OMA in which they're making a sort of argument that when you have a bunch of noisy skyscrapers, possibly using Spellshape, but anyway, when you have a bunch of noisy skyscrapers, that the only thing that stands out is a giant primitive shape, right? This sort of anti-icon. So I thought we'd generate this kind of collage, but in a sort of new era. This one was done in 2017. And in that sense, we can just take any image and in ComfyUI, take a remove background node, which is this custom node, which I kind of covered in the install. But you take a remove background, which is just no AI is being used currently in this ComfyUI workflow. It's just removing a background, right? So it's pretty simple. And you can get other nodes that might give a bit more parameters so that, you know, you kind of fix this little corner here, but for this use, I think this basic one is good. Excuse me, is good enough. Then we just can use clusters now, and I'll kind of cover that when I open ComfyUI. But inside of this cluster, I'm just using the Rhino term. I guess here we're calling it a subgraph in ComfyUI, but by Rhino term a cluster. So there's a bunch of nodes inside of this node, which is generating our text to image process with Flux2 Klein, and just asking for the prompt of an architect wearing black with a nice hat on a camel, which we can use for a prompt. And then we can kind of connect that to remove background, and we've got our camel and our mask. Then Flux2 Klein can also be used, and in this sense, we're going to use a different node for giving an image as an input, which we're not doing on the text to image one. But from a memory perspective and this workshop, that means that this model is loaded once into memory. My GPU is just using one model. If I had to use two models, then my GPU would be getting a bit slower, a bit heavier, because I'm loading two different models into my temporary memory of my GPU. So for this workshop, I think this is definitely the best way to go. But otherwise, I might use some other models that are more specific that might deliver better results. So in this case, I've just asked to rotate this camel and rider around, very basic prompt, and it takes the black suit, the black hat, and the architect on the camel and rotates around fairly coherently, and then I can remove it around. And I'll just show in the slides some other methods that are a bit more advanced than this very primitive method, but still useful in this case. And then basically we can, in ComfyUI, take a bunch of sources, some of them AI generated, some of them just images just copied and pasted into our workflow, and generate a kind of collage space that we just scale and move things around, much like a Photoshop layer, and control the layers to make sure the camel's on top and go like this. This is Education City, which is kind of a building kind of in that style of a giant geometric object that I worked on when I was at OMA, and a bunch of kind of skyscrapers in the background. Then we use an image edit model, again, not taking up too much memory, and give it some prompt, and we can then go to more of sort of flatten the image, give it a foreground, a background. These are basically empty pixels as they move from the left part of the screen to the right part of the screen. And the nice thing about this collage process is, you know, we can kind of just nudge something to the left, nudge something to the right, scale it in a way that controls our way of making this image, in a way that controlling an image with just purely, let's say, a text prompt is very difficult. And often it's like a little to the left, a little to the right, and then you never get what you want. You're just there generating hundreds of images to do what you could just drag, you know, pick this up and drag it to the side of the screen and you're done, right? So it really comes down to control and just whether we have control over how these images are being made. And, you know, as a famous meme, you know, a little bit to the left, a little bit to the right, a little bit to the left, a little bit to the right. And that's kind of what we want to avoid, right? We want sort of workflows that give the sort of designer and the architect control and aren't just going back and forth with text prompts, delivering results that are good, as well using GPU and cloud GPU for, you know, 10, 30 images that are crap because they're not a good way of controlling what we actually want to get. So with moving things around, sliding images out, here's just some images generated of this sort of anti-icon by OMA as a collage of the giant cube with the background of kind of more busy geometries. So that's kind of what I was going to do for part one. Some workflows that I'm not going to cover, I just want to show in slides just to show you what a more, if you were to download more models and maybe make the workflows more complex but more advanced, this is the kind of route you'd go. So SAM3 or SAM2, whichever one is an image segmentation model. In this case, I'm just giving it text man here, and then I'm taking this as the input of the image. It gives me a bounding box and a sort of very neat cutout of the man here, and I can see how I can separate and isolate those pixels and bring that forward to the collage space or any other space, right? And if I change this piece of text in this node here, I can go from man to camel to hat and basically start segmenting everything in a really intelligent way. That's much better than just drawing blobs as I did with the Nighthawk's uh, image. Another one I'm not going to go through, but it's sort of important to know is multi-view diffusion. And that's where you had specific models that would take an image and you would give it the sort of angles of rotation. And you would then sort of rotate this around by 90 degrees. As you can kind of see, the settings are here. This is a very early node from a year or two ago. And I'll show a different version on the next slide. But in that sense, you can take a sort of original image and give multiple angles of it, of this little bit overweight kitty cat, and give it multiple views in order to help with the 3D image or 3D model generation. So you're giving the front, the back, and in that sense, you can sort of spend the time refining the image. And I think generating a good 3D model, if it's sort of image to 3D model, often is a lot of work actually creating the image, and then at the end it's just image to 3D model, but the work is refining that image. So kind of choosing not that back, and making sure that these 6 images are aligned, even though we're just going to do a single image to 3D, that, there is this multi-image approach of adding more control, basically. So more of a, rather than entering the numbers as kind of here of, which, is a bit sort of less intuitive of knowing where you are in space, especially if you're going with a weird angle. Here's just one with a slider. This is a Hugging Face space, so using Hugging Face as GPU, but the same thing exists in ComfyUI with this kind of node that looks like this. And you basically just rotate this way, and we've taken The Son of Man by McBennett and basically got this interesting angle that matches what we've added here. And this is just basically setting two numbers, basically, the incline here and the incline here. Parts is another one that is more complicated to set up, but again, Hugging Face space with OmniPart is one, and that's basically you give it an image. This is MVRDV's Expo 2000, segments it. So basically splitting each of those into separate parts, giving bounding boxes, generate meshes, and they're generating a different mesh for each of the parts that if you were to 3D print them are basically, or you can just separate them in a Blender or wherever, that it's generating multiple meshes that are separable in a way useful for characters, and not used all that much for architecture yet, but it's sort of a very new space. It now works in ComfyUI, so previously this was not open source or kind of available in a sort of downloadable sense, but now there are workflows that to do this locally. And just to show more of a high-res version of this is from Hanyan 3D Parts. So it originally generates this solid mesh, then we'll do a segmentation on it to generate the different parts, and then we'll give these as individual meshes. And if I was to separate each of these elements, the kind of insides are also generated as a mesh in this process. So that's what I mean by each part is 3D printable by itself. So on 3D, here we go with a process of mesh generation in 3D coming from the University of Oxford's Visual Geometry group. And, I loved this paper when it came out. It was March 2025. And it's just basically generating various tiles, and then it allowed this to become a playable game. And I very quickly just went on. I actually did an older version, but anyway, updated with Trellis 2. Just basically give me, do the 2D image of various Georgian brick buildings, and then from that 2D image, go to 3D. And just a very quick way, not a lot of effort, to make a mini city, and you just drag in each one. I would say on dragging into Rhino, one of the issues, and I'm sure there's a short correction to it. I haven't looked into it a whole lot, but the texture generated by a lot of these workflows is just named texture 0. And when you bring in multiple um, meshes into Rhino and the texture is all the same, it basically, every time you import a new mesh, it just applies the texture of the new mesh to all the meshes, and basically would, if you bring in a new building, would distort all the other buildings, and it's kind of a mess in Rhino. And that's why I just quickly went to Blender and did it there. But it's there's probably a short fix to it. I just haven't looked into it about, and it's just a naming issue. If you It's kind of frustrating just to click through all the things and rename all the meshes, but rename all the textures in the meshes. But it's just a Rhino issue with this process as it currently exists. So another project I worked on way back in 2008, even though it was fully built by 2014, I think, and couldn't find the quote, but I think I saw something that the president of South Korea called it one of the coolest projects he ever been to. So that's kind of fun. But it was basically where you have this project here on the right, which is a harbor bath in Copenhagen, in Islambuga, which is very popular in summer. And then this other project, so this one is by Plot, essentially, which is Bjarke Ingels and Julian de Smet when they were together for their first 5 years after leaving OMA. Then they, of course, went their other directions. Then this project is by Julian de Smet. And the shadows cast by these two buildings that were existing at the time that people get out of work was basically across here and across here. So this project basically is the public space on the water that's not in shadow at the point of time of day when people get out of work. And I think it's kind of a fun, clever approach. And this is it kind of in the summer with all the people hanging out on it in 2014. And I thought for this kind of collage part, we'd just look at harbor baths, which Stepan was mentioning earlier. And here's another proposal of a kind of bridge across Dublin back in 2007, where it has kind of a sort of public space and a place to swim, and kind of interesting. And here's a bunch of other ones. Noeta in 2021 in Norway, I think, big in Aarhus, and other ones as well. JDS Urban Agency is kind of a firm of ex-JDS people that did this in collaboration in 2017. And the image from Stepan's part of the presentation that mentioned is the Blackrock Baths. I used to pass this on the train station all the time. It was kind of a very popular place in 1955, and since then is, you know, for my entire time on the train, has been just a derelict site that has needed revitalization. And it's sort of also kind of sad in a sense that the city, and I think many cities, really had a lot of places to swim in the 1950s. Whereas today there's less and less places to do so. A lot of them are more expensive private gyms, and it's not the same sort of everyone has a affordable and cheap publicly owned swimming pool to swim at from back in the day. So I thought we'd basically look at that in form of a collage. I downloaded this and I just put it in the Google Drive. There's many ways that you can get Google Earth tiles, including more automated ways with APIs into into Rhino and into Blender. But this is just a way to, you just zoom in on Google Maps, download the tiles. You're probably on the free, when you sign up for free, only going to get one or two locations. So don't go over the limit if you just want to use the kind of free credits. And I was able to download these tiles from Google Earth of this is the bath area here. And I just deleted the tiles and generated a 3D model with Trellis, which I'm going to show you, and then regenerated the kind of results. So it was kind of a bit, you know, crappy looking in Blender with the kind of low resolution meshes, and then just took the result. But it's nice as a way of controlling a sort of a low resolution space in order to move things around in 3D accurately and then bring that back to the 2D image. And, you know, there's a lot of things within this world, which again, you know, teaching at EAC, I'm kind of interested in efficiency a lot of the time, maybe a bit too much so. But, you know, a lot of these video pros are, you know, sometimes making videos with 256 pixels by 256 pixels, which is barely able to tell out a silhouette of a person, but they do a lot of the computation at this very kind of low file size. and then they basically scale it up with consistency and using LoRa's and things like that. But it's not that they're doing the entire computation at high resolution, which would just be insane. So I think having this kind of low resolution space in order to mess around with things efficiently is important. And then for the final image, we kind of scale up and we don't actually do our whole workflow at expensive computation, and just sort of ask someone to pay the bill. So zooming in, we kind of generate more detail and then plug this sort of zoomed in version back into the original image. So in terms of the collage, I kind of, going back to Stepan's issue, that it's very hard to get an image model to generate a rectangular pool by saying, can I have a rectangular pool? It often gives you a square pool. And it's just crazy that not only the complicated mathematics that Stepan was showing, even just give me a rectangle is hard for some of these image models to do accurately. In that sense that when you use the kind of image to image model and you actually just draw this in Rhino, or you use an image that you get on the internet to say, give me an Olympic swimming pool, that then you get a much better result, and you actually get a rectangular pool. But it's something that's just, a struggle that you need tools, the right tools, and to know the sort of tools that are available in order to get the right results. So, if you want to go beyond generating the mathematical complexity of a rectangle, it's important to have these kind of image to image workflows to sort of have the parts like Rhino that know how to do a rectangle, do that kind of stuff, and then we can bring that into these other parts in ComfyUI. So I was kind of just thinking somewhat around the Yokohama ferry terminal around this. I could have, similar to this one, taken the image of the Yokohama ferry terminal by Foreign Office Architects, then of course split into the two different firms of Farshid Musavi and the guy who taught at Princeton. I can't remember, controversial video when he resigned. And anyway, so we got this image here of something here with a pool, then combine that with the Cube House by Plasma Studio. Plasma Studio is Eva Castro and Holger, who taught at the AA for a while and I think teaches in Hong Kong now. And this is Anyway House. So we kind of quickly turn this into giving a solid black background. The reason the solid black background is just so that we can isolate it to a get rid of the background and then generate it as a 3D model, because we really do want not just segments of buildings, the way that like this kind of fades off into the corner here, but actually the fully enclosed model for the image generation, or for the 3D model generation from an image. And then again, just Grasshopper, and you could do this in Spellshape as well. The idea of inspired by the Giant's Causeway, which is in Northern Ireland, next to Ireland, and just very simple Grasshopper script to give me this kind of attraction script around hexagons that then I can sort of do to pool. And the aim was to kind of combine them together. I guess working in low resolution kind of reduced some of the quality a bit, but it was a collage of types where I have my Giant's Causeway over here, which was meant to be my play pool, my competition pool here, which lost its lanes and definitely changed in scale, and then the kind of changing rooms and buildings coming from the Plasma Studio kind of project. And that's sort of where I was going. And once you get this kind of image, this is kind of done in Blender and then brought back into ComfyUI and sort of said, give me a higher resolution version of this kind of low resolution version that you kind of just screen captured from Blender. And then we can start messing with famous photographers and talking about the golden hour as on here, or talking about this is kind of a photographer who does work in Shenzhen and talking about industrial fog and whatever. So kind of creates interesting, levels of detail. It's a bit of a pity that, maybe I didn't do this at high resolution and captured the kind of faceted nature of the Yokohama project with the hexagon nature of Giant's Causeway, but it's sort of, I think, good enough, and it kind of gets this idea of collage, and you can clearly see the edges differently. And even, I don't think I actually said it in the prompt, which was kind of just AI assisted to generate these kind of long prompts, but I don't think it actually intentionally was given a prompt to say that this was one type and this is another type, but it seems to have given them two different colors, identifying the edge, kind of, which is a interesting perspective. And I can't zoom in on the slideshow, but this is kind of the very big relative to these other people, crazy different scale, but big sort of sunglasses that you would see in a Wes Anderson style production. So that's basically the slides and gives us enough time to go through the other stuff. And so on the ComfyUI, the slides are available and they'll stay available. I've no plans on deleting this, as kind of was mentioned in the chat. And let me just check, was there any chat? Oh yeah, okay. Cool, thanks Caesar and hello. Um, the install instructions, I used to use the portable version of ComfyUI, which gave it its own Python environment. It's a much heavier version, and I kind of realized there's much a better way of controlling it, but it involved installing more things and giving Conda environments to have specific setups when you load ComfyUI. So Git is just so that we can grab things off GitHub really fast. Mini Conda is so we can create separate environments of Python with separate libraries. And we're going to need that for the 3D version of ComfyUI because it doesn't run. If you, by mistake, update ComfyUI to the latest version with this ComfyUI 3D, you actually mess up everything because it doesn't work with the latest version. And it needs a sort of very specific, which was actually quite complicated to do, but hopefully you can reduce this to about half an hour. And if you look on the GitHub, people spent 10 hours trying to install this. So hopefully this goes way faster for you because I've kind of made it in a very packaged, easy to manage way. And do let me know if you have any issues because I'm curious to know that you get on as easy as I hope you get on in installing that because it is a pain in the neck otherwise. CUDA for NVIDIA GPU. You can check in the terminal whether you want to have an NVIDIA GPU and what that is. Not so obvious. You can check how much gigabyte of video RAM you have. So I've got 16 gigabyte video RAM, which is kind of this, 16,000 essentially, which is 16 gigabyte. Yeah. And it gives you the name of the GPU up here at the top somewhere. I think it's under this. Okay, there it is there. It's the name of the GPU. And if you have a 50 series GPU, one of the newer ones, you're going to need CUDA 12.8 because it's not going to run with 12.6. But if you have an older one, you need CUDA 12.6. And that's the sort of thing you install there. And I kind of didn't mention in the slides, but I think it's an important thing to mention that why the GPU is important for all of this stuff. And I I went through with 20 slides of why that's important with the kind of AX students. But I think it shortens to, you could think of a CPU like 8 PhD students or 8 professors. And you could think of a GPU like 3,000 to 8,000 15-year-olds who are really good at math or mathematics. And if you have every single maths question from every exam of every year across the world, who is going to get, for 15-year-olds, who is going to get through those 2 piles faster? And the answer is that 3,000 15-year-olds are probably going to get through that a lot faster than the 8 PhD students, just because they have sheer force, and the problem is not a hard problem for either group. If you have a really hard problem, then the PhD students are probably going to do better. And that's, in a sense, what the CPU and GPU divide is. That GPU is for lots of small, tiny problems and thousands of them. So when you speak about pixel mathematics, that for every pixel, add brightness of 3, which just takes the intensity of every pixel. It's somewhere between 0 and 255, goes through every pixel, adds 3, and you're done. That's a very easy mathematic sum to do, and that therefore the 3,000 15-year-olds are going to do that far faster than the 8 PhD students. And that's why GPUs do graphics well, because it's easy mathematics and it's just sheer force. When it comes to AI, it's the same thing. It's a lot of very simple mathematics, but there's just a lot to do. So that's why GPU is important. That's why the amount of memory is important. And that's why you can run this stuff with CPU, but it's just going to be really slow because you've got those 8 PhD students going through every pixel, and it's just a really intelligent person wasting their time on a very basic problem. And you don't have that many people of it. So that's only really going to work when you get CUDA working. If you have a non-NVIDIA GPU, there are some instructions on the ComfyUI GitHub, which is labeled here, linked here somewhere, or you can just Google ComfyUI GitHub. about how to install Torch with a non-NVIDIA GPU. But for some GPUs, especially older GPUs, maybe they have no memory, i.e. they have no video RAM, they're going to struggle to run things locally. You kind of really want minimum maybe 6 GB of video RAM. 8 is good, 12, 16 is better, 24 is maybe very professional, and you got this very expensive GPU in your machine. Um, but that's kind of important. And that comes down to this PyTorch install here. And you can kind of go with specifically this kind of version for 12 point. Oh, I might have to actually change that. I just realized I copied in. Anyway, this basically 8 here changes for a 6. And there might be some other changes. So I just need to double check all the other settings there. I just realized that's wrong. Whoops. Apologies on that. But anyway, when this works, you can basically in the terminal ask to check CUDA to check if it's working. And that's basically what is going to allow your images to be processed on your GPU and not on your CPU. And that is what's going to give you speed when you're running in ComfyUI. When it comes to actually installing ComfyUI, you kind of activate the environment that you created up here, which gives you the libraries that were installed. Then you clone basically this from GitHub, which is going to basically download everything on this GitHub. Then you change directory to the ComfyUI directory that you just created, and you install what's in the requirements file, which is just a text file of all the libraries it wants installed. And that should be when this environment is active, so it's installed into the active environment. Then you can basically run it by running this command will use Python to run main.py. And that's the way I guess you're meant to do it. However, I kind of wanted a shortcut because I don't like sort of opening the terminal and manually doing it. So this is a .bat file which will auto launch with a shortcut. For quick access, you can just run with python.main.py, but for convenience for later, definitely creating these shortcuts, and that's what's given me my blue ComfyUI for my regular one and my yellow one for my 3D. Basically 2 different sort of installs of ComfyUI. And just download that logo and make that the logo and follow that instruction. So when actually, that's probably not necessary. This SVG write and save param, I could probably delete. That was more for EX students. Download and install custom nodes. So this is going to install some custom nodes in the models. When it comes to the models, Flux2 Client, just basically get that one model working. And basically we have this folder set up of ComfyUI. So ComfyUI basically is going to have this folder downloaded. If you follow those instructions to drive ComfyUI, this is what the folder structure looks like. In the user folder, and this is kind of just, there's only like 3 locations you really need to know. In the user folder, default workflows, this is where workflows will actually be saved if you save them inside of the interface. Then you also want to know where the models are. This is where you're going to place models, and it's very important to go into the right folder as instructed by whatever workflow you're using, because it's the node is going to look, if it's specifically looking for a model from the diffusion folders, it's just going to look for the name in here, and it's really just the name that's being referenced in ComfyUI, and that's there. So if you download, let's say FluxDev FP8 hyphen James's version, and you just rename that in that file, in ComfyUI, you also need to have that exact name. So sometimes you have the right model downloaded, but whoever created the workflow actually renamed Allura or renamed any sort of model, and therefore it's really just looking to match the strings between the file names and what you have in ComfyUI. So just match them out. So that's the models folder for the Flux. There's going to be basically something go in the diffusion models folder. There's going to be something to go into the clip folder, I think. No, actually, that's for Flux 1, but definitely in the instructions, it's where would it be going? There's definitely something going in the VAE folder, and I think it's going to text encoders, right? So I'm putting this is my text encoder instead of the clip model to be used by Flux 2, but it's basically just downloading these models and putting them in the right places. And then the other one to be aware of is output. And this is the default output folder. Typically, it just puts all the images in here in a disorganized way. if you follow the way I'm going to do it, it will create folders and create them by the date, and you can kind of gather input that way. So that's kind of our folder structure. Then these are just common shortcuts when we get into using it. And first test, this is using STXL, but you can check basically. I'll show it to you probably rather than following that part. And ComfyUI 3D is very similar in terms of its install, but it's getting slightly different setup in terms of the wheel, in terms of um, some of the details here, the version of CUDA, so that basically it downloads the right packages to work with the generative AI. And if it happened to work with the latest version of ComfyUI, we could just have one version of ComfyUI, and this wouldn't be this annoyingly complex problem. But if you just follow through the instructions, it should work fine. And I just had this issue on my computer with the remove background node within this custom node. And this is just a quick fix of just this line needs to be added in to convert something to a float. And because it converts it to an int otherwise, and it just makes an error on my computer. So this is a fix for me. I think that will be relevant for everyone, but I'm not 100%. So that's install instructions. And with that, I've already opened, and basically ComfyUI, when you open it, is going to load in this in terminal, and it will automatically open in a domain that's in here somewhere, but it should just automatically open. I'll show that to you in a second. And it's very useful, especially if brainstorming, to actually just copy all the text from terminal and throw it into any kind of LLM to ask for help when something's not working, because this is pretty descriptive about why something is not working, especially with custom nodes and things like that. If I close this terminal, that will ultimately terminate my ComfyUI session, and I will no longer be able to run models. So I can leave this in the background as a terminal that's sort of telling me behind the scenes what's going on. The actual workflow will always load at this, or well, I've kind of set it in the .bat file, but you could choose anything you want. And I've just bookmarked this local address here, but that's where it will generate. So as thumbs up if anyone actually followed all those instructions. I don't know if it's too much to do during the workshop and not have kind of gone through it. Like we got at least 1 or 2 thumbs up. Fantastic. So with that, there's also files that were in a Google Drive folder to show you here that's linked from the Notion. And I basically just have for ComfyUI, for Blender, the site of BlackRock, and you can get your own site if you want. Some input images that I'm going to use. You can, of course, use any of them. You can just Control Copy, Control V from a web browser and get your own images. It's not so important to use the ones I made. And then the workflows that I'm using are here. And interesting thing about ComfyUI is if you have an image, the image actually saves in the metadata, the workflow, and you can just drag that image onto the canvas and it just loads the file. I didn't know images actually had the ability to store things like that, but it's something I guess I've learned that's possible. And you can, of course, drag in the JSON alternatively, but every image produced out of ComfyUI saved in the output folder can be dragged back into ComfyUI, and it will show you the prompt that was used to create it. It basically loads all of the ComfyUI settings at the point that that image was generated, which is a really kind of fantastic way of saving information efficiently, a word you can tell I like. So if I come here and I just look at the 2D process, and if I start here just with I'm just going to grab any image and just go to my unsafe workflow. Just how this whole thing works, right? We we can double click on the canvas. That gives us kind of a search area, and I can type and load image or any kind of node here that's going to basically do a load, and then I can load it like that. Then I can connect this image, let's say, to a resize node. So double click, resize, and you might have, depending on what custom nodes you've installed and if you follow the instructions fully or you're just in the default, but you might have resize or something version of that. And I can see that this is 201 to 251. So let's scale this up to 1000 by 24 by 1000 by 24, which will stretch it. It probably will give us the option to stretch it or to crop it or to pad it. So we can just stretch it and do what we want. And then output is an image. It's not going to show me the image unless I do a preview image. So double click preview image. And that's not going to save an image, which would be save image. This is native. And this, if the prefix is like this, will save into just the regular folder with no none of that folder structure by the date that I kind of mentioned. Then if I was to click this save image and I want to bypass it, I can use the shortcut Control B. And there's only a few shortcuts that are really worth knowing, but Control B is definitely one of them. Now, bypass, I don't think it's often used in Grasshopper, or I can't remember if it's using, I generally don't use it in Grasshopper a whole lot, but anyway, it's useful here in that if I connect resize and then I connect resize again, or I connect, let's say, pad for outpainting, and I've got these two nodes in a track like this. Bypass basically means that the data can flow through the node, but that node is not going to affect it. So because this is bypassed, this node flows to this node, flows to this node, and it just bypasses this one. It still works. If I unbypass it and I use a different shortcut Control M for mute, that it kind of, not so obvious, but it becomes kind of a softer shade. Now that this is actually blocking the workflow because this is turned off. And basically the difference is turned off and blocking the workflow versus turned off and allowing the data to flow. So if I just put a bypass and I scale it and I do a preview, not running for some reason. Is both Stepan and me are getting punished by things not working. That's just... Okay, I'm just going to restart because I have no idea why this basic thing is not working. And to do that, I'm just going to, I can either just X this out or I can go into the manager and just go restart here. Could be also just a refresh browser thing. So now I can see in my terminal, this is like restarting. So I can see basically it loading up here. The more custom nodes that you have installed, especially if they're big custom nodes, will slow it down in terms of the install. So the interface is still working while we're waiting for this to install. But basically over here, we've got workflows on the left, and I can do W as a shortcut, which it kind of reminds me when I do that to kind of go through the various workflows. We're not going through all of these, but there. And then nodes map is a way that I can search the nodes that are in the model. And they all have a model ID, and not that we're going to get into it, but if you want to run ComfyUI headless and run basically create a workflow, but run it without actually opening the interface. You just could get the node IDs off them all by exporting to API and sort of figuring out this is node 29, this is node 36, this is node 31, and then you replace node 31 will take this image, things like that. And I'm just going to hit X. Something is wrong with my computer. That's not normally how this works. Okay, so also, two important keys are these two up here, which are going to empty your GPU. So that's going to unload your models from your GPU. So if you're running multiple models within the same workflows, you can kind of empty the GPU with these kind of things. There are nodes that you can do it automatically on the canvas as well, but managing what is in your GPU is somewhat important when generating everything locally. I've gone from never having an issue with this to now it's not running. Fantastic. I think I might just reset my computer. I don't know what is going on. In that sense, I'll be back in 2 minutes. Apologies for technical error. I'll just see if that makes a difference because this normally would just work. I've not had an issue with this in months. So I'll be back in 2 minutes. Apologies. All right, I'm back. Share screen. So this is loading up. At least it's running now. My terminal, I presume I can be heard. But my terminal, it just wasn't even running before. So this is what it typically would look like. It sort of basically starts at the top and it basically scrolls down while it loads up. And because I have certain nodes installed in one and not the other, it sometimes, the geometry pack failed. And that's the kind of thing that if you copied this into an AI, that it would sort of say this node is not loading or this custom node has got an issue. And that's an issue there. So now I can, it loaded in my other tab, but basically refresh. And now this should hopefully run. Okay, so there we go. So we can see we've gone from 251 to 1024. It's clearly pixelated, but and in that sense that obviously this is the simplest thing ever. This is just resizing an image and it's padding the image for outpaint. Well, it's not actually adding any numbers, but this just means kind of like in the slides when I did the fill on the Medea painting, it's just adding empty pixels to the side. Other padding for, because there's so many custom nodes, like this one doesn't actually have an option here. Maybe it has it under advanced feathering. No, but you would usually have pad with what color. So there's probably other pad image. There's certainly other ones that you would have. I deleted all my custom nodes and I can't. They would often have the option for choosing a color, so you could pad it with a different color and do something like that, right? But this is your basic workflow. Mute there, and we kind of connect different nodes. The rerouting has kind of changed that if you put a node out here and you basically left click and you let it drop, then you've got this add node option and reroute things like that that can be useful for just efficient ways of making things. Then, of course, we have highlight everything, and kind of works a bit weird in ComfyUI, but you hold down Control and then you drag. Holding down without that is going to pan, or left click is going to pan, but left click and holding Control is going to select everything, and then you can move it as a group, just on kind of basics. Control G will actually group it, and we could basically move the group. Dragging something outside the group automatically removes it from the group. So it's not like grasshopper groups. And you kind of, in a way, a bit awkwardly can just resize it that way, and then that's there. Groups can be useful if we were going through some advanced nodes to automatically turn off groups just from a kind of like a remote signal kind of thing of these three groups on, these two groups bypass, things like that. But these are kind of just some of the basic things. And in this sense, we've no AI image model loaded here, and it could be just like an alternative to Photoshop at this point. We could have all these kind of Photoshop-like commands of blurring or patching in a non-AI sense of patching back to the kind of older method of patch in painting. But it could be just like an alternative to Photoshop, and very much is all those kind of tasks that can be done here. So if I just drag, without getting into this process yet, I'm just going to copy in these two nodes by themselves and delete this from here. So this is what's called a subgraph, or a kind of a cluster in Grasshopper, and I can enter the subgraph by clicking here. And I've basically taken a template, reorganized it a little bit. We can add any parameter to the outputs on the outside by right click and, sorry, let me just zoom in a bit here, and right click and promote widget CFG. So this would add the CFG to the kind of outer subgraph interface and do that. I can also just connect things to here, and they will automatically add to this kind of list of inputs, this list of outputs. So for example, this is taking the image size and doing there. I could, for example, make two of these, make one for the width, one for the height, and change the cluster from the outside. It's taking the settings for the models from outside the node. That's what this pink selection is. So that's what the unpromote, it would make it unpink, and I'd set it manually inside the cluster, and then I'd go outside of it. So you can kind of choose what goes in and what goes out. I think for explaining all these things. There was the previous lecture that Stepan did with Albert Suman, and that sort of explains a lot of these kind of basics of what's going on here with these nodes. I can't remember if he went through load diffusion model versus load checkpoint, but it's a slightly different method for Flux and kind of more advanced models to load more advanced versions of Clip, which allow much longer prompts than just loading from the checkpoints folder. But it's much the same of what the previous session from Design Morphine was, and is sort of a fairly simple setup anyway. So we're kind of taking our inputs, loading our models, back to the idea you can load your model anywhere. This is where we're loading our models. Then we're this here, this is the top left corner to kind of close and open anything. It's taking our prompt from outside the subgraph, giving that to our guider, and taking our pixels from outside the thing. And then, not to get into it too much, but you basically are dealing in what is an embedded vector space. So when we say decoding, that's not going from pixels to image. The decoded thing is pixels essentially, or is numbers, which can be represented as numbers, as text, or can be represented as an image, but that's both of those versions are a decoded image. What is an encoded image is the latent space, the embeddings, which is a whole nother topic. But I just wanted to make it a point just so that nobody gets confused. This is not going from numbers of pixels to an image. That both of those things are actually decoded, as it would be. So to get out of a subgraph, I can go to here to this unsaved workflow, and I've got this prompt here. I can click this little dot that emerges outside any of these things on the side, and that would, or should, not working here. That should basically create a string in which to replace it. I think with subgraphs, sometimes it sort of removes that function in a really weird way. But if I was to, let's say, load a checkpoint, I double click this. Yeah, that's what it should do. It should open up into the option, and sometimes gives you more options than would be there otherwise. If I wanted to fix this, I think I know what the problem is. It's just if I enter the subgraph and I depromote this, it's probably more of a bug than a thing. And now, no, it still doesn't work. Okay, well, anyway, it doesn't matter. That was just to get the text into a different prompt, which would then allow it to be adjusted in other ways. But I have this prompt, and I can hit play. And you see now at the top of the screen, we got this sort of green loading window. Also, if I bring in my terminal, which I can add in my other window, I can follow the progress of generating the prompt here. And the number of steps that is used to generate an image, usually not something you engage too much on the closed sourced API versions, but that's a big part of the open source version of how many times you want the diffusion process to occur. The higher it is, the more it does the diffusion. It sort of changes based on the model. There are turbo models that only need to be generated like one or two processes, but in this case, this is going to be 20. So the first time I generate something, it's going to be a little bit slow because it's basically loading it into memory before it even starts. And to load Flux 2 into memory might take 3 to 4 minutes, but once it's loaded in, I can leave it in there and I can get images out in less than a minute each. So here, now it's loaded, and you can kind of see this is going here, it's going here on the subgraph to show that it's going through the steps. And it's very important, again, on efficiency, that the number of steps, if I was to generate 500 steps, it would kind of converge on the right image about 20, and then I would just be wasting GPU power to get to 500. If I have a turbo model and it's generating in 8 steps, well, then generating 20 steps is quite wasteful. So it's important here. The seed, I think, is fixed, so I'm getting almost identical image to what I had before. I'd even almost recognize this as the guy that I had before because the settings are identical. And I'm basically, if you're generating, you need to match this. Again, these are strings matched to what's in the folder. So if somebody has Flux, not hyphen to Klein, not underscore base, whatever. You just need to match it even if it's the same model. And that's sometimes a messy process because people change names a lot. And that's basically all it's to generating an image locally. This is not using the cloud in any way. It's a text to image node, and it's fairly standard. I mean, if I was to go into a more deeper thing about, we could talk about um, using style images to kind of control the output, using LoRa's, using um, control net, using fill and outpainting and inpainting. But like in general, this is kind of the basic thing. And the nice thing about Flux 2 Klein is if I go back here and I drag out my other subnode here, which is the image edit subnode, and I'm going to just drag this one into here. And I'm going to basically connect image to image. So that's basically this image because the preview doesn't actually give me an output. So I need to go back to it, but it's the same pixels, right? It's just the same pixels. And I'm just going to hit another preview and out here. And I can't remember what this is for, but anyway, let's just do Studio Ghibli style camel, man on camel, right? The really nice thing about, and I've said it so many times, Flux2Klein, is it removes the need for all these complicated workflows that it can do a bit of text to image. It can do a bit of image to image. It may not be the best at it, but it's good enough that it just means it's a very small model to load into memory, and therefore it's really efficient to be able to do multiple things within the, especially during a workshop. If it wasn't during a workshop and I was more happier with a slower process, that's fine. I also could load an LLM locally into my thing and actually give a short prompt and then let the LLM expand the prompt, which would then go into the text to image. But again, that would load into the GPU and it would be slower. So I'm not going to do that in a workshop, but that's fully possible within ComfyUI. You could also just load a ChatGPT node, put in your API from ChatGPT. Yeah, so get your OpenAI key, which would then charge, it's a very small amount of money, but anyway, you could then just write a prompt here, then it would edit that prompt and expand it, and then that would connect into there like that, right? So there's my image edit node, right? And these subnodes mean we have this, what is a whole bunch of nodes down, kind of distilled to a very simple interface. It actually is a massive improvement in the interface. So I'm just going to go through, I just want to quickly check the chat. Nothing there. Okay. So hopefully this works. This is just the basics of image generation. I'm going to more just walk through how this works, right? So this is load image, and I've basically loaded in a whole bunch of skyscrapers. I then collapsed a whole bunch of removed backgrounds, and this compositor v4 custom node is going to take image mask, image mask, image mask, image mask. That means I need a remove background that gives both an image and a mask. Some nodes only give the image and don't give the mask, so that would be useful if I just wanted the image, but if I need both, I'd need a different node to do it. And there's often 10 different custom nodes that all do the same thing and have slightly different outputs. So this one works for this one. When you load in these workflows, one thing that's important, as long as the manager is working, that you can do install missing custom nodes, and it will basically, I don't have any missing custom nodes, but it would basically have there, and you would just, from the cloud, automatically do it. It would download them from either GitHub or whatever location the developer has set, and it would automatically, when you restart, do a pip install on the environment you're in of the node. So it's actually a very good way of doing it through the manager to install custom nodes in this way. And I can also search any node here. So let's say I wanted SAM3, I can see this is the one I downloaded from PC Nodes, which is a good sort of developer. But there's these other SAM3 developers as well because SAM3 is by Meta, by Facebook, and different people have kind of made the wrappers for ComfyUI to run SAM3. But that's kind of how you might get custom nodes in. So that's going to run into here. then this is going to create my camel here, which there. And then this, just to show you, if I right click and I do open in mask editor and I do clear, this is Education City that I mentioned as the kind of front of my image. And I can do a brush size of, this is a very primitive way of doing it, but a very fast way of doing it. So I can get a square or a circle, change the thickness, and I'm really just drawing over the image of what I want in my mask and what I don't want in my mask. And all a mask is, from a computational perspective, is an image of the same size as the original image with black pixels and white pixels to to basically work in tandem with the other image in order to say select and do not select. And of course, they work with a opacity as well to sort of say kind of select, don't kind of select, right? And I think the way I did the other one, which is optional, do this. So this would obviously be much better done through SAM3 or through some other form of mask setting, but this is your basic thing, and you have to click save at the top. And that does that. When I did the other one, actually made lighter weight pixels where I changed the opacity on the edge, which is probably a better way to do it, but that's sort of just a setting there. So if I hit run now, it should basically, because these are already there, I don't know if it's going to run again. Which part's running? Okay, it's yeah, okay, that was what was running. It created that image for me. Now let's move around this, right? And this is a custom node, and basically this is, I can move these here. So I want this guy to be at the front. And I want this building to be at the front. And it's kind of annoying to select them. It's not as kind of nice as a normal software, but I can kind of left click any one of these and then go up here and center it if I lose track of it, and then control the scaling of it and do things like that. So basically make my composition here, text prompts coming from here, and then I push play again. And because this is already run, it might not run. Basically, if something is run in the past, it's not going to run again. So I might just change the seed value by 1, and that means this node in this current setting has not been run, and it's going to rerun. So now I can see this is rerunning. And because this Flux 2 is already in memory, it's just ready to go, and it's already working it out. And I can, again, go back to my terminal, and I can see 20 steps, and it's on its way there. And I can see other things from the terminal. And this is what I mean about like this text here copied into any LLM has an amazing way of just diagnosing any problem that's going on with this text, because it just reads here and it's like, oh, this is true here. It should be false, right? And it just detects things really, really fast. So and I think when I edited in this and the other one, I made the width and I entered the subgraph and made the width and the height appear on the edge so I could edit that from the outside, because I can't do that here. So I forgot what I actually had here, but the Studio Ghibli version, that was the last image I did in the presentation. So in this sense, I can generate a collage of images by removing the backgrounds, assembling it. And that's basically what I did in the slides that I showed you. So there's not a lot of time left, and I don't want to go too over time, so I'm just going to basically explain some of these other workflows. Downloaded, I probably didn't name it the best, but anyway, the Flux 2 version is where I did the majority of the work, and I basically have left everything bypassed as default. I started off with a text prompt with Flux 2 that just shows you I'm kind of hoping this does not generate a good example, but it shows you that saying, give me a rectangular swimming pool often results in either an out of scale swimming pool or a square swimming pool. And it's just, It's just not the most accurate way of generating geometry. And I think bringing Spellshape and other things in that are where you can actually just set a rectangle or anything more complicated mathematically is a very important addition to this world. Okay, it gave me a rectangle. It's still scale, really messed up the scale. But it's still not the best way of generating images. I got a lot of squares, even though I asked for a rectangle. So um, in these other ones, I basically sort of said do a rectangle, and I could run all of these, and it's basically um, unbypass each one of these one by one. And if I had them in groups, I could do it in a more efficient way, but I'm trying to keep things simple. Um, and I basically generated just the exact same way as I did for all of the other examples. It's the same workflow essentially. The only difference is when it came to the last one, I basically changed this here to flux 9 billion parameter rather than flux 4 billion parameter, which will give me a slightly better image, but these are bigger files, requires bigger GPU. Um, You could, of course, just change these back to the 4B and do it that way. But this is basically generating those final images that you said and that you saw. And I can just control the width and height from inside the subgraph here. So in this case, I asked for a bigger than 1024 by 1024 pixel image. And that's basically just generating the assets for 3D. So I'm just going to close down this version of ComfyUI and open the other version just to show you the 3D model generation really quickly. So I can basically just on the terminal, just close it, right? And it's not going to close here, but now nothing is going to run in here because it basically has no backend that's running here. And I can open with my shortcut my 3D version of ComfyUI. And one thing that's nice about this trellis models, even though, it's relatively advanced what it's doing, it runs not a whole lot slower than generating those images. It's a really fast process at generating 3D models. And I didn't actually change it, but I thought about changing it in the .bat file. If you were to change the link from 81888 in the regular Comfy one to 81889 in the other one, then they would actually load, because when this loads now, it's going to automatically open and automatically say it doesn't have access to the last loaded file because none of these custom nodes are in the other version of Comfy UI. So this is going to run this version. And this is the 3D workflow. And all I'm really doing in terms of this is I'm giving it an image. I need to remove the background of the image. You could install any other remove background in. If you're going to use the trellis one, you probably need to do that little fix with the float that I mentioned in the setup. I'm just going to hit play, or actually load it in the file. I was messing with, I don't know if you know 100 Architects in Beijing. This is one of their playground structures. I was potentially going to add that in, but I didn't in the end. But it was just a fun kind of thing that they did. So if I push play now, it's going to generate a new one. While that's loading that model into memory, um, I can see it's already at 8%. Basically, or actually, that's probably just something here. This is removing the mask here. I could, of course, preview the mask, which is going to be different from preview image. It needs a different node. And I could preview the mask just to make sure the mask is correct. That one you're probably not going to change. For the settings for mesh generation, I kind of created this markdown here that you can kind of see minimum, maximum, and default of what's kind of there. This is generating 40,000 tokens per mesh. You could reduce that, especially if you're on a smaller GPU. You could increase some of these settings to generate higher resolution meshes. If you're on a lower GPU, you could definitely reduce this last texture size back to 512. And that's kind of somewhat on this chart that's here of minimum, maximum, and default. So if I was to output this, I don't have a preview here, but this is generating a 3D model with no texture. And then the next step is to generate the texture, again, coming back to the conditioning, which comes from the image. Which you could have fun making a cocktail of the wrong texture to the wrong 3D and see what happens. It can be an interesting little experiment. And this would run slightly faster if it was already loaded into memory. But here we go. It's almost there. And again, you could sort of edit these settings, which I have, I think, here, hopefully. Definitely doing a 2048 texture is, quite large in terms of the memory requirement. And if you see this here, this is the image that actually came with the custom node. And if you zoom in, it's really high resolution and detailed, and there's been a lot of effort to make sure this is a really detailed model. And I might actually just run this one after I finish this last one. So I see here, I can see that it didn't generate the best on the hex thing, and this is what I brought into Blender, but it's good enough there, and you could basically play around with the settings, generate a more higher resolution version that would take a bit longer to generate, and that might fix the problem in terms of getting back to our Giant's Causeway version of that. This can be then, if I zoom in, sorry, zooming is being annoying, this menu bar and export and then download. And I can download this as GLB, bring that into Blender, and this is just a save. It's going to ask where do I want to save it, just like the regular kind of thing. There. So if I just reconfigure this one, and just to say this one is configured that the mask is already removed when it's loaded. So in this case, I need to invert the mask. And because if I didn't invert the mask, it would actually take all the empty pixels that's not the image and forget about the image. So it just needs to be reversed. So I'm going to take the inverted mask, and it doesn't need to be removed because it's already removed. And this is the image, and I'm going to run it again. And there are other trellis workflows that are multi-image for more control, things like that. But I just want to show you this one because it's 1042 by 1042, but it's incredibly detailed, and the level of detail of a 3D model, even with these settings not pumped up to their maximum, is still really phenomenal, especially compared to 6 months ago. I was using Hunyan 2.1, which is what you can get in the cloud right now from Comfy Cloud, and this is so much better. And I'm sure we're going to say that every 6 months for the next several years. And I guess I'm not going to go through the Blender part, but it's basically just assembling the images, screen capture them, and bringing it back into the same work, the exact same thing. But the nice thing about this is the same workflow basically applies to everything. So if we look at the accuracy of this 3D model from that image, not a fan of promoting weapons of war, but anyway, it's the example they give in the custom node, so I'm not taking responsibility for that. But all right, so that's there. And hopefully, I think if I proved any one thing, it's how much you can do locally, as in this is not connected to a cloud anywhere, and yet it's in a minute generating a pretty decent result. All right, that's all from me. I just quickly look at, is there any questions, or I don't know if Mike's still there. I'm going to stop sharing my screen. Well, I guess if nobody's there, well, thanks everyone for joining, and share results, tag us in them. I think the links to tag us are well in the chat, well documented everywhere, and
Hey,
look forward to
James.
seeing. Great. Yeah.
Hey
Sorry.
guys, that was awesome. Really cool, like collab workflow there. And yeah, super excited to see what people will do with it. I hope that you'll all share some results with us. Um,
And thanks very
make
much,
sure,
Mike, for having us. Fantastic.
yeah, make sure if you make something cool with these workflows to tag us, and we'll check it out and reshare it. Yeah. And so, yeah, after this is finished, we will, you'll get an email with the recording um, to watch on Zoom. And then sometime after that, it will go on to YouTube public. And so you should subscribe to the YouTube to get notification for when that goes on.
Great. Thanks for all the kind words in the chat, everyone.
Yeah. Until next time, see everybody. Enjoy the
Bye,
rest of your days or nights. Bye.